In this video, you will learn to describe why organizations use the Linux operating system,
Hello everyone, my name is Alex Campos. I'm CM Administrator in MSS IBM Security, and today we are going to start with the Linux course for beginners. So, Linux is a multi-user, multitasking operating system which provides a number of facilities including management of software, resources, directories and file systems, and the loading and execution of programs. The Unix operating system got started in 1969 at Bell Laboratories and was written in assembly language. Then, in 1973, Thomson and Ritchie succeeded in rewriting Unix in the new language that was C. In September of 1991, Linus Torvalds released the first version of what was to become the Linux kernel. Torvalds greatly enhanced the open source community by releasing his license under the GNU license. The GNU license is a widely used for free software license which guarantees the end users the freedom to run, study, share, and modify the software. Now, why Linux? Well, the system is flexible enough to allow users to build applications with a wide variety of support tools such as compilers, scientific libraries, debuggers, and a network monitors. Linux has also four essential properties which make it an excellent operating system for science community: performance, functionality, flexibility, and portability. The performance of the operating system can be optimized for a specific tasks, such as running small portable devices or large supercomputers. Now, how does the Linux work? Well, there are two major components of Linux: the kernel and the shell. The kernel is the core of the Linux operating system, which includes the processes and interfaces directly with the hardware. It manages the system and users, processes, devices, and files, and memory. The shell is an interface to the kernel. Users input commands through the shell, and the kernel receives the tasks from the shell and performs them. The shell tends to do four jobs repeatedly. 1. Display the prompt. 2. Read the command. 3. Process and give in the command. And 4. Execute the command.
In Module 1, you will learn about cybersecurity compliance frameworks and industry standards recommended or required for organizations to implement, to protect, and defend critical data. You will explore relevant laws, including the Computer Fraud and Abuse Act, or CFAA. The IBM team will take you through data protection regulations, including GDPR, General Data Protection Regulation, and industry-specific regulations like HIPAA, the Health Insurance Portability and Accountability Act, as well as PCI DSS, the Payment Card Industry Data Security Standard, which is an information security standard for organizations that issue credit cards or process credit card payments. As you learn about cybersecurity, it is important to review the Information Security Management Systems, ISMS standards. ISO 27000, family of standards, helps organizations keep information assets secure. Lastly, we will take you through two sets of security controls: the CIS Critical Security Controls, which are a recommended set of actions for cyber defense that provide specific and actionable ways to stop today's most pervasive and dangerous attacks, and the NIST SP 800-53 database, which represents the security controls and associated assessment procedures. This module has a lot of information around standards and compliance, but I will be here to help you navigate through the lessons in this module. We have also included a glossary within Module 1 that you can refer to throughout this course. Are you ready to get started? I'll see you on the flip side. In this video, you will learn to describe the challenges organizations face, which require compliance and regulation,
Welcome. My name is Catherine Franklin. I'm Program Director for Compliance and Audit Readiness at IBM in the Cloud and Cognitive Software Division. So today we're going to be talking about different topics associated with compliance and regulation for cybersecurity. There are a number of different compliances and standards and laws, and we'll try to detangle some of that for you and give you some places to start as you consider these topics for your own purposes. So first off, let's get some definitions set. We have different types of security definitions. We have security events, attacks, and incidents. And they're all related, but they're different. A security event is a system or network detected by a security device or an application. So this can be any normal activity from entering a password. That's a security event. It can be a firewall rule check. That's a security event. It's not the same as an attack. An attack, of course, is a subset of the events, and that's when you actually have some entity or tool or person attempting to do something malicious or untoward with your system. It can be trying to collect data, corrupt your system, create a denial of service, destroy your system, anything like that. Any attempt of that is an attack. An incident then is when IBM and the world at large would consider it something worthy of deeper investigation. So we think that possibly something bad actually happened. So we had the attack, which was the attempt, and we had the incident, which means we think maybe something actually had happened, and we need to go and figure out what happened and what we're going to do about it. So the challenge for security is that, of course, there's so many of these events, right? You're always entering your password. There's always something that's checking something else. This is a report from the 2015 Cyber Intelligence Index from IBM, and they identified in the cloud space that there are roughly 82 million events in 2014, of which 12,000-ish represented an actual attack, and 100 represented an incident. And this would be for an individual system. I think a big misnomer or a big misconception people have is that their systems are somehow safe because they're not seeing things. Well, probably you're not seeing things because you have firewall rules and other activities that are in place, and they block a lot of that for you. So what you're really seeing is the distilled things that you're actually concerned about. But the main objective is how to put in the security controls that you need to for all of these events so that you can find, prevent, and protect against the attacks and the incidences. Well, there's no one way that you protect a system. There's hundreds of different ways that people will attempt to maliciously attack your system. There are, so you need multiple different facets and approaches. If you again look at the same study, 2014, they looked at the different sources or types of security attacks that were identified. We have unauthorized access, malicious code, sustained probes and scans, access credentials, denial of service, right? So you can see a whole list there of different ways that people are, that attacks break down into different categories. And even who your bad guys are, that breaks down into main categories. You can see about 45% of all bad guys are outsiders. They are not part of your business, they are not part of your environment, but they are trying to get in. These are the hackers of the world. These are the they can be individuals, they can be organized crime, they can be a number of different sources. The other 55% represent insiders. These are people that may be working in your own organization. You know, you think, okay, I know and I trust everybody, but the truth of the matter is that some folks are in your organization may become dissatisfied over time, and so you'll see a number of malicious insiders. You can also see inadvertent actors on the inside, right? So these inadvertent actors are people that have access to your systems as part of their normal days and functions, and we're human, they make mistakes. So we need security protocols and controls and tooling and processes in place to try to address the different types of security incidences we can have, as well as the different sources they can come from. You get tired of entering your password every day, all the time? Well, it's there for a reason. It's there to make sure that you have, like, they all have a purpose, each one of these things. And it's not about having any one security protocol in place to help you, but about having a set of them to address the different scenarios. So think about this. You've got an outsider. He wants to get in. The outsider wants to get in. They want to steal your data. They want to steal your compute time. They want to disrupt your legitimate use of your products, of your services. You've got to look at different techniques specifically addressed for them. You're looking at encryption. You're looking at firewalls. You want to validate these through reviews, through tests, through threat models, penetration testing. There's lots of different ways you're going to deal with that particular actor. The inadvertent actor are on the inside, but are human. They're making mistakes. You want to make sure there that you have systems in place and procedures to reduce error-related controls. You're going to be prompting for confirmation of things. You're going to be looking for automation to reduce human data entry errors. And so you're going to look at different sorts of automation and reports and things like that to try to prevent those things from happening. The malicious insider, they're inside, but they're deliberately behaving badly. So there you want to make sure you focus on things like separation of duties. You want to make sure you have limited privileged IDs. You want to limit the access to your critical systems, your critical data to just the fewest people possible, reduces the risk that those people are malicious. And you want to make sure you have individual accountability, so no shared user IDs, and you're logging and monitoring whatever those limited IDs are actually performing, and you're reviewing that on a regular basis.
In this video, you will learn to describe the difference between security and compliance, describe the specific checklist of security controls.
So we're going to go through some compliance basics. And the previous talk was mostly focused on security, but we're going to go through compliance basics at this point. And what we're looking here is really understanding some of the differences between security and privacy and compliance, and how that is going to unfold as we look at different compliance standards and regulations. So security, privacy, compliance, they're all related, but they're not actually the same thing. Security is designed to focus on protecting your environment and your systems from theft, from damage, from disruption, from misdirection. It comes in three main categories. There are physical controls. So how do you physically keep your systems that you're operating your applications on contained, right? So there's servers and data centers. They may be in the cloud. How do you ensure the physical security of the hardware? Then there's technical controls. Technical controls are tooling or software or features and functions that restrict or control the security of the data or the processes. So you can think of encryption. You can think of logging. You can think of password software. All of those are examples of technical controls. Operational controls are more the procedural. These are how a server is configured. What are your rules for how often you patch a system? Who's responsible for monitoring the logs and reviewing them? How your staff are trained and what activities they perform. These are operational or procedural controls. So security of your system isn't going to be addressed with just one defense. It's going to have many, and they typically fall into one of those three categories. Privacy is a little bit different. Privacy is strongly focused on the data. So how the information is being used, who has access to it, how is it stored, how is it transferred, how that information may be used to track people or things, and that is privacy about you as an individual, for example. Compliance focuses on testing the security measures are in place or the privacy measures are in place. Compliance will typically identify a specific subset of all of the controls based on a particular goal, and then the idea is you validate those specific controls to that standard. So this will, it can also cover a lot of non-security things that you wouldn't typically think of as security. So business practices, vendor agreements. You don't typically may think of vendor agreements as something related to security, but certainly if you don't build your product and run your product on your own, you have vendors that participate with you, you need to ensure that they're providing the security and privacy controls that you're expecting of them. So it's related, but maybe indirectly for some people's perspective. So compliance, when you think about compliance, as I said, depending on how you articulate security requirements or individual requirements, there can be anywhere from 50 to 500 controls out there that are involved in securing your environment, your system, your product, your application. So depending on which compliance you're going after, you may be choosing a specific subset of that 500. So once you've identified that, you're going to want to validate. They would validate on a schedule. Typically, you would validate that with either an external auditor or another assessor inside your own company. We have assessors inside IBM who perform that function. And then we're looking at sort of proving out that those controls are being adhered to and are in place. Sometimes, depending on the nature of the particular compliance, it's worthwhile to consider having an external vendor who specializes in that particular compliance. They come in and they do an assessment. They can do an audit. They can do the standards will each govern whether what they're doing is an assessment, an audit, or a report, or a certification. So that terminology is all kind of particular to the individual compliance. We're going to go through some of those in a little bit later. Compliances. There's really two main categories for compliances. So what you'll see from compliances is some are foundational. They're general. They're not specific to any particular industry. They are broad spectrum. They go over a number of different topics, be it physical or the technical or the operational. Examples like that would be ISO 27001, SOC, which we'll get into in a bit. And then there are other classifications that are more industry specific or governmental even, and they are particular to specific subject matter. So an example is what we'll see here later today. We've got HIPAA, which focuses on U.S. healthcare. We have PCI DSS, which focuses on payment card information, so credit card data storage. And there's European standards. Many jurisdictions will have, the U.S. federal government has several standards. So we'll be going through some of those as part of this conversation. And you as a security cyber specialist would want to understand kind of when and how each of these apply and what's appropriate for your business, because that's where you're going to want to order up, right? These are all, some of these are very expensive to do. You have to choose the ones that are most appropriate to your industry, most appropriate to your business needs, and focus on the going after the ones that will provide you the greatest business value. Typical compliance process for initially getting that certification or that compliance, you want to establish the scope. So if we want to go after ISO, I want to go after it for this particular set of systems, this particular application, this particular environment. So you want to establish the scope, very clear boundaries of what is in your compliance and what is not. The readiness assessment, you go through all of the compliance requirements for that particular standard. You look at the controls, you look at the specific subset of the 50 to 500. You want to understand how each of those controls applies to your environment that you've established scope on. Then you want to assess how well do you perform that function. I perform that function well, I don't perform that function at all, I perform it sort of, but not great. So you'll identify gaps as part of that readiness assessment. Once you've identified the list of gaps, then you've got some homework to do, right? You want to go and you want to address those gaps. You want to remediate any findings that you've had so that you've made corrections. So if you don't have encryption everywhere that you want to have encryption according to the standard, well, then you'll go and you'll add it. If you haven't got if you haven't got your user IDs, you haven't got the individual least privilege, maybe you want to go through and review who has access to your system and trim that up. So you'll go through that gap remediation, and then you'll enter a testing period. If you're testing it through your self-assessment or internal assessment, you'll work with experts in that area. You may also be engaging external auditors if that's the appropriate thing. Once the testing is completed, whatever certification or assertion or reporting is usually follows some period of time after that. It can take some period of time to finish off the reports and testing. Then you'll be recertifying. Right? So depending on the nature of the certification, sometimes you're recertifying quarterly, recertifying annually, biannually. It really is going to depend on the terms of the particular certification you're going after, but they all generally fit this mold. If you found yourself partway through testing and found out maybe that you didn't complete your gaps appropriately enough, you may be circling back to the beginning and reestablishing your scope or redoing your gap remediation. And basically, though, you'll be cycling in this for the lifetime that you intend to support that particular compliance.
In this video, you will learn to describe the Computer Fraud and Abuse Act.
So we're going to talk now about a few specific different topics in U.S. federal law and different compliances going forward. So we'll get into some specific examples and talk a little bit about them. First one we're going to talk about is in the U.S. federal law space, the Computer Fraud and Abuse Act. So the Computer Fraud and Abuse Act has been around since 1984. It basically is what makes it a crime to perform that makes cybercrime a crime. So it is a law that identifies that access to a computer without authorization, or in excess of your authorization, is against the law. It is against the law to interfere. It is against the law to acquire, to disrupt your systems, and it's punishable. So it's an act that prior to 1984, computers were in use, of course, but they fell under the standard mail and wire fraud rules, but now, since 1984, it's been a separate law. There are other U.S. federal laws, FISMA and FedRAMP, that look at assigning specific responsibilities to federal agencies. If you do business with the U.S. federal government, you will have to be supporting very strong physical requirements, technical requirements. Each agency within the U.S. federal government can have a different subset of standards that they need to have met as part of this. And so you end up with this one is very complex. My advice to you is if you're going down the U.S. federal law space, like, this will be a devoted topic in and of itself, an entire research project from an education standpoint as well as acquiring it. But these U.S. federal laws will base their subset of their requirements off of something called NIST, the National Institute of Standards and Technology.
In this video, you will learn to describe the importance of the National Institute of Standards and Technology, NIST.
The National Institute of Standards and Technology is focused on cybersecurity and privacy. They will identify literally hundreds of individual standards that are related. There'll be pages and pages of details on passwords, on encryption, on network communications, and how to assure security and privacy. There's not generally an expectation that you will implement many hundreds of these things, but that you'll institute a practice within your business to do as many of them as make sense for your business. And as I said earlier, depending on which agency you're working with, they will have specific subsets that they'll be looking for.
In this video, you will learn to describe the General Data Protection Regulation, GDPR, Describe the key privacy and data protection requirements of GDPR.
GDPR, or the General Data Protection and Regulation laws, are a European standard that came out recently. They are laws governed at privacy of European data. So they focus on compliance, data protection, and personal data of EU residents in particular. So if your business is going to host EU resident data or do business with the EU, then this is an important regulation for you to understand. So from a compliance perspective, they're looking at regulating how you manage the data associated with people, making sure you have policies and processes in place. They're specifically looking at data encryption, data security, access and monitoring to data, and then personal data, a lot in the privacy area, and how to ensure that the data is there lawfully. You also see laws here around the right to forget. They also come with incredibly stiff penalties. So it's been around since 2018. As I said, it applies to anybody in the world, regardless, as long as the data that you're working on is European, it is going to be a law for you. Fines can be huge, 4% or up to 20 million euros, depending on your company's revenue. You can Google GDPR findings, and you'll see that they have some serious fines attached to them. We've seen multi-million. I've seen fines in excess of 100 million euros. So the 5 key tenets there are the rights of data management for EU subjects, the security of that personal data, the requirement to obtain consent from the owners of that data, we'll get into that a little bit, and the accountability and the data protection. So key terms here that you'll want to understand is the data subject. That's the identified or identifiable natural living person. So that's the EU resident. The controller, this is the person who is, or entity that is responsible for the handling of that data. And the processor. And the processor could be an actor on behalf of the controller that is processing the data. So if you're, let's say a bank would be considered a controller, but if you were providing an application to the bank and the bank was running your application, you would be a processor. So personal data is any information related to the subject. So this is something that's often misunderstood. They think that if it's somehow detached from identifying the person, it's still personal data. The processing is any person performing that data or any entity performing that data. That's storage, that's access, that's transfer. And as I said earlier, it's global, it's anywhere in the world. So the law governs the data, not physically where the data is.
In this video, you will learn to describe the basics of the ISO 27001 standards.
ISO. We're going to spend some time looking at ISO 27000 family of standards. ISO, of course, has many different standards, but the ones in particular that we're interested in here are the ones that are applicable for cybersecurity. This one particularly focuses on information assets. 27001 is the most common one. It is an information and security management standard. It focuses on requirements for establishing and implementing, maintaining, and improving your security management system. It's risk-based, so it's looking at the risk and the maturity level of your organization. So great that you have password protection. Do you have password protection? What is the complexity of your password protection, right? So as you increase the complexity standard associated with what you're implementing, that's how you move up the maturity level. There are others in the family. There are many in the family, the ones that are relevant for our conversation today. We look at 27018, which is focused on privacy, and 27017, which is focused on cloud security. Of course, that's my background in cloud. We use a combination of these 3 security standards as part of our comfort and assurance that we are able to meet requirements of things like GDPR. we would hire external auditors who would come in and assess and provide us certifications in this space. So the certification process provides credibility to our clients that we are achieving the standards expected. The advantage of an external auditor coming in and doing that assessment, we can provide that report, is then the clients aren't required to go and do individual assessments. They can look at the report, they can look at who performed it, they can look at the terms of that, and they can say, yeah, that's as good a standard as testing as I would have done, and it can really help you because you can provide that one standard to many clients rather than have clients perform individual assessments. There are some industries, some jurisdictions, some situations where the certification or having it is actually a legal or contractual requirement. So if you want to do business in certain geographies, you'll either have to do an individual audit or you have to be able to provide it. ISO does develop standards, but they don't themselves issue the certification. You find a authorized, qualified, accredited certifier or auditor to come in and perform that assessment on your behalf. And then you would have a certificate. Typically, you get a certificate, and that certificate is something that you would put on your website and shout loud and proud because it demonstrates a lot of hard work. It identifies a standard that is, attractive to your customers.
In this video, you will learn to describe the differences between SOC1, SOC2, and SOC3 controls. Describe the benefits of SOC reports.
SOC reports. So spend some time now looking at SOC reports. So SOC reports are some industries will require it, just like we mentioned earlier for ISO. Some jurisdictions or industries would require it. And if you don't have it, they'll accept. You have to perform some local compliance audit. So many organizations who know compliance actually prefer SOC 2 over ISO. ISO is a point-in-time testing, whereas a SOC 2 is a continuously monitored testing over a period of time. So, and again, some organizations or some clients or some industries will accept SOC 2 in lieu of the right to audit. So if I could compare with ISO, and I look at the different types of things that they focus on, just to compare and contrast, is you'll find SOC 2 is focused on physical and logical security, and in specific, do you do what you say you'll do? Whereas the ISO one is a little bit more focused on risk. ISO is internationally recognized. SOC 2 has traditionally been more North American, but it is becoming more known internationally. The purpose in the test for SOC 2 is that you achieve the standards associated with the control, but also that you implement your own policies and perform them. And the ISO one is a little more focused on best practices. The ISO is managed by the an ISO accredited agency would do the consulting and the certifying. SOC 2 is almost always performed by CPA because it's governed and spec'd out by the AICPA. In the difference about design and the nature and scope, as I said earlier, ISO is focusing on the design effectiveness or point in time, whereas the SOC 2 will also look at operating effectiveness over a period of time. So type 2 would be 6 to 12 months, and it would look at how effective you were performing those functions over that entire period of time. You get a single page from an ISO certification. There's a detailed report that's considered confidential and internal, but otherwise it's a single page and doesn't provide a lot of detail to the reader or to your customer about what you're doing. In the case of SOC 2, you get a fairly detailed report. It can be many pages long. It describes the controls, it describes how they tested them, it describes the results of the testing. So it's very, very detailed and can provide a lot of insight for your customers and confidence to your customers that of how you operate. Again, personal opinion, I consider the SOC 2 a higher degree of difficulty over the ISO because of that operating effectiveness component to it. So SOC 2, there's actually, I called it SOC 2, but there's actually 3 SOC reports. SOC 1, 2, and 3. The SOC 1, they're all based on the same core set of controls, but they subset it out and report out differently. So SOC 1 uses a subset of the controls, and it specifically is looking at situations where your system is being used for financial reporting. So if you are using your system to hold your sales ledger data, and you then are going to turn around and use that data to generate reports for your financial reporting, for your SEC filings, things like that. So you will, so it's going to focus on a very specific subset of reports, and they're going to be slanting it towards that purpose of financial reporting. Not surprising when it comes from the AICPA. SOC 2 is a little more general, and it's going to look at more controls, a superset of the ones that are looked at for SOC 1, and they're looking at it for general purpose use. The report they produced is restricted because of the detail that is in there around the system, the security, the processes, the methodologies. If you achieve this for your environment, you would keep a copy of it yourself. You would only send it to clients or prospective clients under a non-disclosure agreement because of the level of detail in there. If it fell into the wrong hands, somebody could use that to try to mount a malicious attack. For people who do want to have something short and sweet and something you can put on your webpage, like the ISO certification, there is a SOC 3 report. It is considered an executive summary of your SOC 2 and is used to provides the opinion and the description of the system, but it does not get into the details of the security practices or the testing methodology and results. So it's just a high level one. And so typically what you would do is you would commission at least a SOC 2. If you have the financial needs, you would also commission the SOC 1, and the SOC 3 would come as well when you get into the type 2 situation. So you can do one audit and achieve all 3 certifications. You just need to plan that out with your auditor in advance. SOC 1, SOC 2 come in a type 1 and a type 2. You need to kind of keep a little chart. I'm going to have to make a little handy chart to keep track of these. But a type 1 report, consider that your starting line. That is the closest equivalent to an ISO as well. So basically it tests the design effectiveness of your controls and has tested that you have performed those controls at least once. So think of that as the start, type 1. And you would use that when your product is new or when you are first acquiring your certification for SOC. It's not something you would ever repeat. You'd just do one type 1 report. After that, you move into a type 2 scenario. And the type 2 is now looking at operational effectiveness over a period of time. Typically, that's 6 months or 12 months. And so the auditor will come in and they will test over the interval of that period of time. So if you're doing a 6-month test, and they'd come in after 3 months and run tests on the first 3 months, and then come in at the end of the 6 months and then do some more tests. And basically they're looking that the control is operating effectively on day 1, day 30, day 180, etc. The expectation there is that you're able to provide proof that you're maintaining your effectiveness of these controls over time, and typically you will renew them either every 6 months or use them yearly. We do rolling 12-month reports typically in our business, so we would have every 6 months we would report out on the previous 12 months. This is very helpful for our customers who are looking at using this for their businesses, because then they have continuity for the entire period that they may be using our product. On top of the complexity of type 1s and type 2s and SOC 1s and SOC 2s, there are different principles or chapters within SOC 2, and they each come with a set of controls or requirements. The most typical and sort of the foundational one that everybody would get would be security, and they're looking specifically at how you're protecting your physical and logical access and systems. So you have controls related to user provisioning, change management, inventory management, things like that. And then we have other additional principles or chapters, and you can determine which ones are most relevant for your business, and of course increase your the scope, the number of controls, and the scope of your audits and the reports. Availability and confidentiality, processing integrity, and privacy We're starting to see, we're definitely seeing availability and confidentiality, and we're starting to see more interest in processing integrity and privacy as well. So you can see the industry shifting from having kind of entry-level securities, baseline, we're going to get that, towards having these more complex and additional controls added on. Confidentiality and privacy are really useful as you also help to try to prove out your GDPR stance for your European customers.
In this video, you will learn to describe the audit process for SOC reporting.
When auditors are testing, as I said, they're looking at that continuity. They're testing for 5 main elements. And these elements are, they can be very particular. Right? The SOC 2 is not for the faint of heart. It's a very challenging compliance to achieve. So they're looking at accuracy. Are all the controls being addressed? Looking for passes and fails and very clear distinction about whether or not the control is being completed. Completeness. Do the control cover the entire offering? So, if you're in case of a control looking at your systems, does it cover all your systems and all your inventory? If you're looking at access management, does it cover all personnel, all people? Looking at timeliness. Timeliness is a really big challenge for some teams, right? Making sure the controls are performed on time or early and that there's no gaps in coverage. So if you're supposed to apply your patches every week, being a day late creates a gap in your coverage area that could potentially be a risk for a malicious attack or something inadvertent to go wrong. So they're looking at timeliness in particular. If for any reason that you're unable to perform a function on time, there can be really logical reasons based on your customer's business needs that you would say, I'm going to, I've got a peak period going on here. I'm not going to be patching during that peak period. So if the control can't be performed on time, have you done an appropriate risk assessment before the control is considered late? So if you were supposed to patch on Friday, but your customer called and said, hey, we've got a promotion thing going on. I don't want to patch on Friday. I want to wait till Saturday. If you've got an appropriate reason, you've looked at the business risk, the use case, you could say, yeah, it's safe to wait till Saturday. You need to have had that all documented in advance. Don't wait till Saturday to document it. Document it on Thursday so that you're not late. Resiliency, they're looking for checks and balances so that if a control did fail, is there some secondary way that you can ensure that something happened on time? And they're looking for consistency. So they want to ensure that there's no gaps introduced by having too much variability. So often they'll look at a primary control, they'll test the primary control, they're looking to ensure that you provide features, functions of the control. If for any reason that's not working, they're looking for support or backup to ensure that the primary control is effective. So if you have access management approvals records in place, are you periodically reconciling those approvals with what's live in your system to make sure that no one has circumvented your access management system and created somehow an access account on the side, as an example. So this is a summary listing of the different controls that are used for audit. You can see they just kind of break down into different chapters. These are chapters, by the way, that we use for our own purposes. You can go from the raw set of requirements from the AICPA. What's really important, regardless of which type of compliance you choose, whether it be ISO or SOC, is continuous monitoring between your audits. We talked a lot about the different ways that you could potentially fail a SOC 2 audit, but even for ISO audits that are point in time, you want to know that you have the controls operating as designed, that they are performing their functions, and that all the communication is going out to whomever they need to go out to. You're looking to test your environment, your processes, and your people to ensure that the continued execution of the controls. So we call that continuous monitoring. You're looking for any risk of deviation, any time where you have a temporary failure or a delay, and you'll want to try to identify those effectively, because there's no point in having a standard if you're not making sure you're actually performing that standard. So this is an important aspect.
In this video, you will learn to define the 3 rules established as standards for the Health Insurance Portability and Accountability Act, HIPAA. Describe why HIPAA compliance is so important to an organization. Describe key HIPAA terms.
We're going to focus now on some more industry-specific types of auditing. So the HIPAA, or the Health Insurance Portability and Accountability Act, is a U.S. federal act for healthcare information. The note 1P, 2 A's. It is a dead giveaway if somebody actually does 2 P's and an A, that they are new to this process. So healthcare organizations are using cloud services to achieve savings and scalability, and there's a lot of concern about putting sensitive data in the cloud. Is that a good thing? Is that a risk? Well, that's why it's important to understand security and understand the provider that you're working with, and making sure that they've understood that this is important to ensure that we have the integrity in place to provide the security and the safety and so on. But certainly our customers are looking at cloud more than ever to increase resource utilization, reduce costs, increase response time. So HIPAA is the U.S. federal law that identifies the control of personal healthcare information, so PHI, personal healthcare information. And it's also related to the other law in this space called HITECH. The privacy rules associated with the HIPAA identify the right to an individual's medical records and health information, and that it is accessed, again, very strictly accessed to those who need to know. It applies to health insurance companies, to healthcare providers, and anyone who might have access or need to share healthcare records. The security rule establishes a set of standards for protecting that data, and they must be in place for both the covered entity and the business associate, which are similar to what we would have, I'll define those in a minute, but they're similar to what we saw in GDPR. So the HIPAA is defined and managed and overseen by the U.S. Department of Health and Human Services, the Office of Civil Rights, and they identify 2 main actors in this space. There's the covered entity. So this is the company that manages the healthcare data for the customer. So it would be a hospital, it would be an insurance company, it could be your doctor's office. A business associate is any vendor that supports the covered entity. So if you are providing an application, if you are providing a cloud environment to the hospital, then you are a business associate of that covered entity. The protected health information is any information about the health status of the individual, and it is the responsibility of the covered entity, or on their behalf for the business associate, to ensure its safety and confidentiality. Now, in the case of GDPR, we talked about large fines. There absolutely are large fines here for violations of HIPAA. There's also a wall of shame. You can go to the website there, and they will produce that. Okay, so why is compliance here essential? So there are laws, the U.S. federal laws, and they have teeth, and the HHS will come in and do unannounced audit either on the BA or the CE, so the covered entity or the business associate. One, the other, or both could find themselves under an audit situation. The fines can be in the millions of dollars. You can face criminal prosecution, so serious stuff. So although it's a U.S. regulation, the other thing to be aware of is that many other countries will have a similar law. We talked about GDPR. In Canada, there's the Personal Information Protection Environment Documents Act. So just about every geography is going to have a similar law or regulation on the books. Many states in the U.S. will have even more strict laws or additional requirements that are laid out on top of the U.S. federal law for HIPAA. And so you need to be aware of that as you're choosing your jurisdictions you're doing business in and the types of compliances that you're aligning with. Some international companies will also require HIPAA, whether or not they do business with U.S. data or U.S. customers or they just see it as a valuable standard and they have confidence in it. So you'll see that being required internationally too. Okay, HIPAA security rules will cover physical entities, technical controls, administrative safeguards, all with that focus on protecting health information. They look at confidentiality, integrity, availability, and they want to ensure that we've taken all steps and actions to reasonably anticipate threats to the security and integrity of the information. You want to protect against impermissible uses, accidental disclosures, and ensure compliance by all of the workforce. Administrative safeguards, they take the form of these are the non-technical or operational controls. They're looking at your management process, your personnel process. They'll look at hiring practices, workforce training, background checks, things that you're doing to ensure the integrity of the people and the processes they're performing. Technical safeguards, again, like the general term, technical, they're looking at access control, audit control, integrity control, transmission, encryption at rest, in transit, in use, different physical controls to make sure, technical controls to make sure that the software is performing as it's expected. And then the physical safeguards are around the facility access, where the devices are. So if your data is stored on disk somewhere, where are those disks? Are they appropriately under access control and are they secure? They're also looking at access points, so workstation and device securities as they do it. So if you're in a hospital, think about all those computers that are sitting on people's desks out in the public area. The workstation device security is focused on all of those access points and making sure those access points are properly secured. Timeouts on workstations, for example, to make sure that if you got up and left your workstation for an extended period of time, nobody could just swoop in and start using it.
In this video, you will learn to describe the payment card industry data standard security, PCI DSS. Describe the goals and requirements of PCI DSS. Describe the scope of PCI DSS as it relates to people, process, and technology. Highlight new and key requirements for PCI DSS.
Payment card industry data security standards. So one of the things that you see quite a lot in the public space, and if you look at the latest data breaches, it's around who gets access to somebody's credit cards. They're an incredibly high value target for people who are looking for malicious access to your systems. So back in 2014, 2004 rather, the set of the largest credit card companies, American Express, Discovery, MasterCard, Visa, they banded together to define a standard for data security. This security standard gets revised periodically over the years as new standards and new technology become available. And these companies will require, if you're going to be engaged in any business that involves storage or transmission of credit card data, that you secure that data to these standards. So store, process, or transmit credit card holder data. That's credit card numbers, any of that sort of thing. It covers both technical and operational practices, so the administrative as well as the technical controls for the systems. And there are a total of 264 different individual requirements in 12 different groupings. So not, if you're engaged in an audit for PCI, one of the first things they do, remember I talked earlier about defining scope, how many of these, what is the scope of your environment and how many of these 264 apply to you. So you'd go through the 12 different categories of these requirements, from building and maintaining a secure network, protecting cardholder data, managing a vulnerability management program, access control, monitoring and testing your networks, and maintaining information security policy. You go through all of these different categories. You'll do an assessment. That's that whole readiness assessment we talked about in the scope, where you identify these different requirements and say how many of them are applicable to your environment. So, and they'll all do it in the context of understanding that the data that is at risk here, the data that they're protecting, is cardholder data. So cardholder data environment is the people, process, and technologies that store this. In particular, looking at the primary account number, or PAN data, and it can be the cardholder name, the expiry date, the service code. They're also looking at sensitive authentication data, so PINs and PIN blocks, or anything else that is used to authenticate a credit card transaction. And they're looking at, again, ensuring that anything that processes, transmits, or stores this data is considered in scope. So they're particularly looking at people, processes, and technologies. So they look at everything from your human resource aspect to this, to network device management, network segmentation, audit logging. There's a number of different topics that we're going to look at here for this. And you can see, as we're looking past over the last couple of requirements, they're all sort of similar and overlapping, and they just may each have individual unique slants. One of the things that's unique about PCI is they have this concept of an approved scanning vendor that scans quarterly, usually quarterly, and it's usually an external third policy. It's similar but not the same as a vulnerability scan or the penetration testing you might see. But it is a very specific and approved nature, and it's something that you're expected to perform uniquely. One of the other things that we consider somewhat unique relative to other requirements are the details around Nessus. There's particular configurations if you're doing scanning for vulnerability for Nessus, and file integrity monitoring. File integrity monitoring is when you ensure that all the files that are running on your system are the ones that you intended to be there, and nobody's replaced an executable with a different executable, same name, that's also performing. So they're checking for skimmers as an example here. Firewall rule frequency, review frequency is increased to 6 months. Some other certifications might only require it once a year. We've always taken something like this and said, if we want to make sure that it happens right at least once every 6 months, do it at least once every 3 months. Then you have at least a couple of times to do it. So you may want to do something more frequently than the spec requires to guarantee that you've got it achieved at least once during that interval. Automatic log-offs during idle sessions, they're set at 15 minutes. HIPAA, for example, is 30 minutes, so you can see some different things there. One of the documents that gets produced from PCI is a responsibility matrix, and that's a really good document for you to review because it clarifies what are the responsibilities of the entity providing the PCI support and the consumer. So in this case, when we talked about a hospital and a cloud application, in this case we might be talking about a bank or a business that is using credit card, has a web portal for purchasing, and you're storing those credit cards for that purchasing arrangement. So that what you do and what your consumers do is your responsibility matrix.
In this video, you will learn to describe the Center for Internet Security, CIS, critical security controls. Describe the differences between basic, foundational, and organizational CIS controls.
CIS is a set of security controls. Again, it's the Center for Internet Security. They produce a set of standards too. So you can get the theme here, right? Everybody's producing a list of standards of what's important to them. The critical security controls are what the Center for Internet Security believes are the set of in-depth best practices required to mitigate against systems and network, common attack systems and networks. So in particular, we look at their controls from a configuration perspective, right? How to best configure systems sitting on the public internet so that they are reasonably protected. And we see a lot of experts using these from retail, manufacturing, healthcare, across a wide variety of things. So the key difference between this so an example of a control here that is CIS governed is, say, passwords. You're setting up a computer for the first time. You can choose to have passwords on, yes or no, right? Anybody with common sense is going to say, yes, I want passwords. But if you want, you'll notice that when you use passwords at different sites, the complexity of the password could vary, right? Do I need 8 characters? Do I need 15 characters? Do I need uppercase? Do I need lowercase? Do I need numbers and punctuation? Well, that's an example of a security configuration that each business will decide what is the appropriate configuration that I'm going to do. And CIS has a set of configuration benchmarks, and one of the things they would govern, for example, is password complexity. So we see a lot of different basic foundational organizational controls in here, and I've just talked about a couple of examples here around passwords, but you can see they cover a number of different topics: vulnerability management, boundary defense, application security, incident response and management. I haven't talked about that too much before, but let me take a minute and talk about incident management. It's one thing to say I've got all these controls in place and I have all these practices in place. But we talked earlier about security incidents. Something is going to go wrong, or somebody's going to perceive that something has gone wrong. Who gets called? How do you know what to do about it? Do you have lifelines out there for your customers, for your employees to be able to call and say, I think I see something wrong. I think I see an incident and we need to respond to it. So a protocol in your organization around incident management is an important part of most security postures. CIS breaks their controls up into 3 implementation groups. They base them on the maturity or the significance of the controls and of the organizations using it. So if you're a mature organization, enterprise, you're going to look at group 3. Small, single storefront, maybe group 1 is more appropriate to your business. Each of the controls is documented as to why you're doing the control, what the different parts are, what the tools and procedures would be, and an example of how you would organize it. So that concludes our talk on different types of controls. I've put a summary of different controls that we've talked about here at the end. And this is just a cheat sheet to kind of try to keep them all straight in your head. Wish you well in all your security and compliance activities. Thank you.
In this video, you will learn to define a client as it relates to a computer system, define the characteristics of client system administration, describe why effective client system administration is important to cybersecurity.
Hi there. Today we're going to talk about client system administration. And when we talk about a client, it really is in the context of a client accessing a server. So a client will be anything that really accesses a server application, like a web server, a mail server, or a file server. And a client can be anything like a desktop computer, a laptop, tablet, and even smartphones. Anything that is used to access resources that sit on a server is really considered a client from an IT perspective. And a single server can really have many, many clients that talk to it, and many clients can access that one server at one time. So it's not a one-to-one relationship. It's typically a many-to-one server relationship, and one client can also access multiple servers that have different purposes. So for the purpose of this discussion, that's really what we're talking to when we talk about a client. It's any system that will access resources on a server. So when we talk about the context of client system administration and cybersecurity, we're really looking at it in a couple different ways. And you know, you're all going to be familiar with cloud and mobile computing. We all have our smartphones that we access apps, and most of those apps will operate in a typical client-server methodology where the app is actually accessing some kind of server resources that are hosted somewhere else, typically in the cloud on an AWS or an Azure or an IBM cloud or any of the other myriad of cloud hosting providers that there are. New devices and new applications and new services are coming into organizations all the time as people load applications, as new line of business applications are coming online. It's really an on-demand kind of world that we live in, and that leads to lots of potential threats that could be present as those new applications come online. And really, endpoint devices are the front line of attack. That's how most bad actors or hackers will try to get into an organization, is by accessing an endpoint or a client and then branching out from there. So malware will be installed based on a website that someone goes to, or a phishing attack, or a spear phishing attack, or ransomware. Any of those kind of attacks can lead to large problems within an organization. Let's talk a little bit about the common types of endpoint attacks, and this is just a very small list. There are lots of endpoint attacks, but phishing or spear phishing is an email which imitates a trusted source designed to target a specific person. That's spear phishing. So think of a spear as in a very sharp point, and that sharp point refers to the specific person that you're trying to attack. I've also heard the term whale hunting, where a person will try to attack a very specific person in an organization, like a C-level executive, and that's what we refer to when we talk about whale hunting. When we're talking about a spear phishing attack versus just a normal phishing attack, spear phishing is going after a particular particular person in an organization, again, that pointed attack, or a specific department, versus a phishing attack, which is a mass email that would go out to everybody within an organization, and anybody who clicks on it would be the target of that attack. A watering hole is malware that would be placed on a site frequently visited by an employee or a group of employees. So, you know, we're trying to just get anybody who would go to that site. They click on a bad link that installs some malware on the endpoint, and then I'm in the organization and can branch out from there and try to get the information that I want. And then these ad network attacks, so using ad networks to place malware on a machine through ad software. So I click on a link on a website that again goes to download some malware on an endpoint. And then again, I'm in the organization to do whatever activity I want, install malware, install ransomware. You know, we've all heard about these ransomware attacks that are focusing on public sector entities. Like the city of Atlanta had a very large one last year. The city of Lake Florida had one earlier this year. So they're becoming much more prevalent, and really are becoming a big deal for organizations. Island hopping is a supply chain infiltration. I'm really not as familiar as that with as I am with some of the other ones, but I'm assuming that would be where we try to infiltrate someone's supply chain to disrupt business operations or to get information about the organization's supply chain in order to cause problems or to get information that we could potentially sell. And really, when we're talking about endpoint attacks and malware, the whole goal of this is to make money, right? I mean, whether it is to disrupt a competitor's business operations, or it's to directly blackmail the company to get money from them to not release that information, or to decrypt information that we've encrypted through the malware, and that's really what ransomware is. But the whole goal of this is to make money. That's why people do it. It used to be, when you talked about hacking, you know, when we talk about movies, and I'm going to date myself here, like war games, it was just to get in to see if I could get something. Now what we're seeing are organized attacks to specific organizations for the sole purpose of getting money from that organization, either in the form of disrupting their business activities, or direct, you pay me and I'll give you back your information. So that's really what we're seeing in the threat landscape when organizations are trying to hack other organizations and disrupt their business activities.
In Module 2, you will begin to learn processes that would help your organization meet regulatory compliance requirements. First, the team will explain the components of client system administration. What is a client as it relates to systems? What is endpoint protection and some best practices to keep your systems safe? And how patches fix vulnerabilities. Finally, you will explore how to devise a patching process to protect against threats. Let's begin. In this video, you will learn to describe how endpoint protection works, describe an example of endpoint protection.
So let's talk about endpoint detection and response. So endpoint detection and response, or EDR, is kind of a newer term that has come up. It is protecting the endpoint and responding to attacks in addition to or on top of more traditional antivirus solutions. So you're probably familiar with antivirus and how that works, and the things that we're trying to protect on a specific endpoint and prevent viruses from causing problems to the endpoint. But EDR goes a step further than that. So it has some capabilities associated with it, which are deploying devices with network configurations. It will also do things like automatically quarantine or block non-compliant endpoints. So if my EDR solution sees that I don't have a particular patch level, or I don't have particular software installed, then that EDR solution would block me from being able to get to anything on the network, on the corporate network, until I get to that patch level, or get the requirements, or I should say the prerequisites that are needed in order for me to do that. And typically, when we quarantine an endpoint, the only thing that we're going to get access to is the actual EDR solution for those patches or those applications to be downloaded and put on that endpoint in order to make it compliant with policy. It will also have the ability to manage lots of devices at once. So my EDR solution will have the ability to distribute patches to all of the endpoints in my environment, so that I can keep them compliant and give them the requirements they need to access resources on my network. Endpoint detection and response has those kind of things we talked about before, like automatic policy creation for endpoints. So I can create policies that will tell me what the requirements are, or set the requirements are for endpoints to access things on the network. They will also be able to do things like zero-day OS updates. You've probably heard of zero-day vulnerabilities, where there weren't really any heads up to those vulnerabilities, and they're very quickly patched and remediated by an EDR solution. And then it provides also continuous monitoring and patching, as well as enforcement of security policies across all the endpoints in my environment. So it's giving me that ability to manage every device in the environment in order to keep them up to date and minimize the vulnerabilities that can be exploited by someone who wants to get in my network. So when you're talking about an endpoint security solution, there really are several facts to consider when we're evaluating them. One is threat hunting, my ability to go and see what threats are present in my network and minimize them, or find out what happened when a threat has been detected, and do some investigation around that. How am I going to respond once I've found a threat? So am I going to quarantine? Am I going to segregate that machine from the rest of the network? What am I going to do to investigate to minimize what's going to happen to the rest of the environment when I do find something that's going on? So how am I going to respond to that? And then also user education is really important. What you'll find is that about 50% of events, security events, are actually insider events. And when we say an insider event, it doesn't necessarily mean that it was malicious. It could be an accident, but it was caused by an employee going to a bad website, or clicking on a link in a phishing attack, or some other way that I have been infiltrated, and it was through an employee's ignorance or malicious behavior. Like I said, it doesn't necessarily have to be malicious behavior, although that is something to think about. So user education is really important because of the amount of threat.
In this video, you will learn to define endpoint protection, describe the basics of endpoint protection.
So let's talk a little bit about how we protect from those attacks. So when we talk about endpoint protection, it's really a policy-based approach to network security, because we're really securing the network to prevent the endpoints from being attacked, or to minimize the number of attacks that are going against our endpoints, and we do that through network protection. So network policy, network security, it really requires that endpoint devices comply with specific criteria before they're granted access to network resources. So those endpoint resources need to be at a particular patch level. They need to have specific software installed, such as antivirus and endpoint detection and response software. You know, each organization is different in what they require for endpoints to be installed in order for them to access network resources. But it is a policy-based approach, and typically the security organization within a company or public entity will establish those policies in order to best protect the network and therefore endpoints from being infiltrated. Endpoint security management systems are typically a software or a dedicated appliance, and they discover, manage, and control those computing devices that request access to the corporate network. So really what that means in layman's terms are the security management systems are tools that help on a mass scale protect your endpoint. So it's things like antivirus, it's things like patching solutions so that we can en masse patch endpoints and bring them up to the current level to reduce vulnerabilities. It's anything that protects the endpoint that is managed by the company's IT organization. And endpoint security systems typically work in a client-server model. So you'd have a centrally managed server or centrally managed appliance that would provide that policy to the endpoints in the organization that we're protecting. So like I said, it could be an antivirus, it could be an EDR solution, but all of those solutions are going to have an application that typically resides on the endpoint, or an agent that resides on the endpoint, and then that is centrally managed either through some kind of website or a console application, any way that I can centrally manage and see all the endpoints in my environment to manage them and to provide protection around them to minimize hacks and minimize infiltration into the system and to prevent those bad actors. So one of the concepts that has really gotten a lot of press lately is the concept of unified endpoint management. As we continue to broaden how we're accessing resources on the network, things like smartphones and tablets and laptops and desktops, we want to have a single pane of glass, if you will, in which we can see all of our devices. And that's really what unified endpoint management is all about. It's a platform that would converge traditional client management techniques like a Big Fix or like a SCCM or any of the solutions that are out on the market and combine those with what we call an MDM application. MDM stands for mobile device management, and typically manufacturers of your mobile devices like Apple and Android, the two largest ones, will provide APIs, which are what are called application programming interfaces, so APIs into the operating system so that I can protect them. And a unified endpoint management solution will combine those traditional client-server management techniques with those MDM APIs so that I can manage my entire environment. Mobile device management or enterprise mobile management, both terms can be used, really provide solution around mobile devices, but not so much around typical client-server devices. Now, that being said, newer operating systems like Mac OS and Windows 10 do have some MDM APIs built in. So many MDM providers like IBM's Mass 360, like AirWatch and Mobile Iron will have some capability to manage both traditional MDM applications, so they manage typical mobile devices like Apple and Android, as well as some management capabilities around Windows 10 and Mac devices. But a true unified endpoint management platform would be able to manage all of the resources in your environment, not only mobile devices, but also endpoints like desktops and laptops, as well as servers, Unix devices, Linux devices, and that's really what we're talking about when we talk about MDM, is the convergence of all those management platforms into a single pane of glass, if you will.
In this video, you will learn to describe how endpoint protection works, describe an example of endpoint protection.
So let's talk about endpoint detection and response. So endpoint detection and response, or EDR, is kind of a newer term that has come up. It is protecting the endpoint and responding to attacks in addition to or on top of more traditional antivirus solutions. So you're probably familiar with antivirus and how that works and the things that we're trying to protect on a specific endpoint and prevent viruses from causing problems to the endpoint. But EDR goes a step further than that. So it has some capabilities associated with it, which are deploying devices with network configurations. It will also do things like automatically quarantine or block non-compliant endpoints. So if my EDR solution sees that I don't have a particular patch level or I don't have particular software installed, then that EDR solution would block me from being able to get to anything on the network, on the corporate network, until I get to that patch level or get the requirements, or I should say the prerequisites that are needed in order for me to do that. And typically when we quarantine an endpoint, the only thing that we're going to get access to is the actual EDR solution for those patches or those applications to be downloaded and put on that endpoint in order to make it compliant with policy. It will also have the ability to manage lots of devices at once. So my EDR solution will have the ability to distribute patches to all of the endpoints in my environment so that I can keep them compliant and give them the requirements they need to access resources on my network. Endpoint detection and response has those kind of things we talked about before, like automatic policy creation for endpoints, so I can create policies that will tell me what the requirements are or set the requirements are for endpoints to access things on the network. They will also be able to do things like zero-day OS updates. You've probably heard of zero-day vulnerabilities where there weren't really any heads up to those vulnerabilities, and they're very quickly patched and remediated by an EDR solution. And then it provides also continuous monitoring and patching as well as enforcement of security policies across all the endpoints in my environment. So it's giving me that ability to manage every device in the environment in order to keep them up to date and minimize the vulnerabilities that can be exploited by someone who wants to get in my network. So when you're talking about an endpoint security solution, there really are several facts to consider when we're evaluating them. One is threat hunting, my ability to go and see what threats are present in my network and minimize them, or find out what happened when a threat has been detected and do some investigation around that. How am I going to respond once I've found a threat? So am I going to quarantine? Am I going to segregate that machine from the rest of the network? What am I going to do to investigate to minimize what's going to happen to the rest of the environment when I do find something that's going on? So how am I going to respond to that? And then also user education is really important. What you'll find is that about 50% of events, security events, are actually insider events. And when we say an insider event, it doesn't necessarily mean that it was malicious. It could be an accident, but it was caused by an employee going to a bad website or clicking on a link in a phishing attack or some other way that I have been infiltrated, and it was through an employee's ignorance or malicious behavior. Like I said, it doesn't necessarily have to be malicious behavior, although that is something to think about. So user education is really important because of the amount of threat.
In this video, you will learn to define patching, describe why patching is important to avoid cybersecurity threats.
Now what we're going to talk about is patching, and patching is really important regardless of the operating system you're talking about. You know, we hear about Windows patches because most of us use a Windows PC, and we see that little notification in the right lower corner of our screen that says, hey, your machine needs to be rebooted. We've installed some patches, and we can't make them effective until you reboot your computer. But patching is really the same regardless of what the operating system is. And it's really important, and frankly, the fundamental and most important thing that an organization can do in order to protect itself from malicious events occurring. We've all heard the news about how companies got hacked. We've all heard the news about ransomware. There's lots of examples in the U.S. of public institutions like cities, the city of Atlanta, the city of Baltimore, city of Lake City, Florida are recent ones that I can recall where they were subject to ransomware. They were asked to pay a ransom, and when we talk about ransomware, it is somebody gets into the system, and it's usually a foreign entity, and they will put some code on there that essentially will encrypt everything on that hard drive. And that will propagate to all the machines in the environment, rendering basically all of those files and folders useless unless you pay a ransom, hence the name ransomware. And that ransom is usually in the form of Bitcoin. And once that ransom has been delivered, then you will be given the key to unencrypt all your files and get your files back. Now, the folks who have paid are very successful in getting their files back, but many organizations and municipalities have said, no, we're not going to pay, and they've spent much more than the ransom on the cost of recovering those files. So the net of it is it's just really important to patch and to keep your systems up to date. And I went off on a little tangent there, but I think that's just important to talk about a real-world example. So when we talk about patching, and as I said before, this is whether you're talking about a Mac, whether you're talking about a Windows system, and whether you're talking about a Linux or a Unix system, patching is really the same from the concept of why we do it. The mechanisms of how we do it may be a little bit different depending on the operating system, but why we do it is the same. And a patch is really just a set of changes to a computer program or its supporting data designed to update, fix, or improve it. This includes things like security vulnerabilities, other bugs, and that's why some patches might be called bug fixes. But we also, when we talk about patching, talk about patching the operating system.
In this video, you will learn to describe how patching works, describe patch management best practices.
So in the context of Windows, Windows Update, which we're all probably pretty familiar with, allows to fix known flaws within Microsoft products and the operating systems. There are modifications to software and sometimes hardware, because you may have hardware drivers that have a vulnerability in them, and they help improve performance, reliability, and most importantly, security around that system. Microsoft, and we're, like I said, we're just using the concept of the context of Microsoft because that's what everyone's most familiar with. They release their patches in a monthly cycle, and most people in the industry call that Patch Tuesday because they do. Microsoft releases its patches the second Tuesday of every month on Patch Tuesday. And there are really 4 types of updates for Windows OSs, but these are also the same across other OSs, Linux and Mac as well. And those are security updates, which are really probably the most important updates, and many organizations will not deploy patches other than security updates. They feel that application updates and going to a newer version of a particular version of Microsoft Office just to expand features don't really make a lot of sense. We're mostly concerned about security updates that patch vulnerabilities in the operating system. Those security updates are classified as critical, important, moderate, low, or they may not even be rated because they're not viewed as important. And many organizations will only patch critical and important security updates. So it just depends on the organization and what their philosophy is around patching. Because sometimes, and this is not always the case, but sometimes a patch may cause issues within other applications that are needed to do the organization's business, and that's why they choose not to patch everything. So there's a lot of testing that goes into place with patching within a large organization or even small organizations, because we need to make sure that the patches that are released will be compatible with our environment. And that's why patching, even in 2019, is still a big challenge. I've been focusing on patching for the majority of my career, so everybody has said for the last 20 years, patching, is basic stuff and isn't important. Well, it's important, and we find that it is actually more and more important as cybersecurity events continue to occur. Second kind of updates are critical updates. These are high priority updates that may not be security updates. So they may not be classified as a security update, but they are still considered critical. There may be a bug in an application that causes something, and that critical update needs to be applied. So as I mentioned before, many organizations will only apply security updates and critical updates to the operating system, and then they just don't worry about the other ones because they don't want to test for compatibility. Software updates, which are released by Microsoft, are not considered critical. They are things like feature upgrades or reliability upgrades of a particular software that don't have to do with the vulnerability. So if say Microsoft Office crashes every month and a half, if I'm doing something very odd and they release an update to that, that's not as important as a security update, because that's not something that can be exploited by a bad actor. And then there are things like service packs. Service packs are roll-ups or a compilation of all the previous updates to ensure that you're up to date on all the patches. They also may include feature updates or feature enhancements to the operating system, but typically a service pack is a roll-up. With the way that Microsoft has kind of changed their patching and their update strategy, service packs are probably going to be a thing of the past. If you talk about, say, Windows 10, Microsoft has kind of placed a stake in the ground and said Windows 10 is going to be our our only operating system. We're just going to add functionality onto that, and then so service packs are really not something that is really as important as it used to be. So let's also talk about patching applications. And again, when we're talking about applications, it doesn't matter whether we're talking about Windows or we're talking about Linux or Unix or Mac. And when I talk about patching applications, I'm mostly talking about the third-party applications that every end user has on their system or even most servers. So things like Java, things like Adobe Flash, and there are other ones, i.e. any web browser. Those are things that really are as important or sometimes even more important to patch than the operating system itself. In fact, 80% of the vulnerabilities found in the top 50 cybersecurity programs were affected third-party applications such as Flash Player or Reader or Java or Skype or media players and things that weren't part of the operating system. So when end users, or I should say when organizations talk about patching, the ones that take cybersecurity most seriously are ones that treat application patching as seriously as they do operating system patching. And most organizations that I work, they patch on a monthly basis. And for Windows, it centers around Patch Tuesday. So they will have a process where the Patch Tuesday patches are released, and then they will go through a testing process or a vetting process, if you will, where those patches and any third-party patches that came out that month will be distributed to endpoints within the organization to what they call a test group. And that typically is folks in IT or virtual systems that are considered part of a test. And then they will launch their day-to-day applications, either custom applications or off-the-shelf applications that are needed to run the business, and make sure that there are no compatibility issues with those patches that were released. And then once those compatibility issues have been highlighted or checked that there aren't any, then those patches will then be distributed to the broader organization to make sure that the machines are patched and are not you don't have vulnerabilities that can be exploited. So that's kind of a primer on patching, but it is a very important and time-consuming process for many organizations. So, but as I said before, it's an important part of cybersecurity and something that needs to be done on a regular basis.
In Module 3, you will learn about server and user administration fundamentals. What is the principle of least privileges and why is it important to an organization's security? How is role management, privilege delegation, and root access control set up for Linux servers? You will learn about roles, role services, and other features in Windows Server. You will research the existence of compliance regulations for server administration and complete an exercise to help test your ability to learn about current and future requirements in cybersecurity. Are you ready for the challenge? In this video, you will learn to describe the Windows components user mode and kernel mode and how they differ.
Hi there. I'm going to talk to you today about a few quick concepts for Microsoft Windows. Let's jump right in. Microsoft Windows developed by Microsoft Corporation, has been around for a long time. Pretty much anyone who has used a personal computer within the last 20 years probably has some experience with Windows. But really the best part about Windows is it created the first graphical user interface that we're used to. So where you can go in and use a mouse to point and click instead of having to type in commands. And it was designed for IBM compatible PCs. So obviously Macintosh and Apple devices will run their own operating system. Windows will run on what we call IBM compatible PCs. IBM, as many of you may know, created the first personal computer in the early 80s. Approximately 90% of PCs worldwide run some version of Windows, and servers as well run versions of Windows as well. So it's something that many of us are very familiar with. So there are a couple components associated with Windows, or there are a couple components that Windows uses. They have a user mode and kernel mode components. User mode is really what you see when you are opening an application, when you're using Microsoft Word, or you're surfing the web with Chrome or Firefox or anything like that. You're really accessing user mode. And there are drivers that are used by that to create that I/O, that input/output that you're leveraging when you use an application like Microsoft Word, or, as I said, a web browser. And then there's the kernel mode, which is kind of the underlying technology within Windows, where you have different processes and threads that actually control the applications that you're leveraging within Windows and within the user mode of Windows. So let's talk a little bit about the user mode. So when you start a user mode application, Windows creates what it calls a process for an application. Anybody who's gone into Task Manager can see when you have applications that are running, you will see those processes running inside the Task Manager that will tell you things like how much memory it's using, how much CPU, and CPU is your processor, how much processor it's using as you use that application. The nice thing about applications is they're really pretty segmented from each other. So when you start an application, that virtual address that is created are private. So it's segmented from other applications within the environment. So one application can't alter data that belongs to another application. Each application runs in what we call isolation, and if that application crashes, it's not going to bring down the entire operating system. It's only going to bring down that application. So other things that are going on are not affected by that crash. If we talk about kernel mode, everything that runs in kernel mode contains a single or shares a single virtual address, so that kernel mode drivers are not isolated from other drivers and from the operating system itself. So if a kernel mode driver accidentally writes to the wrong virtual address or to something else within the operating system, that data within the operating system could be compromised. So if a kernel mode driver crashes, the entire operating system would crash. So you may have seen that where you get the blue screen of death, as it's commonly called, when your operating system stops and you have to reboot. That's typically caused by a kernel mode failure or a driver within the kernel mode writing to virtual address that would cause an issue with the operating system.
In this video, you will learn to describe the NTFS and FAT file systems used by Windows.
Okay, so let's talk about the different file systems that are prevalent within Windows. And a file system is what enables applications to store and receive files on storage devices. When we're talking about storage devices in Windows, we're mostly talking about a hard drive. So what's installed in your computer, it could be a spinning platter, which is a mechanical device, or it could be a SSD, a solid state drive, which is a non-mechanical device that stores that data. Files are placed in what we call a hierarchical structure. So you may have folders within folders within folders. And the file system will specify naming conventions for files and the format for specifying the path to a file in that hierarchical or tree structure. Just for definition's sake, a file is a unit of data in the file system that a user can access or manage. So a picture file is one file. It might be a JPEG or it might be a PNG file, but that's what we consider is a file. And every file has to have a unique name in its own directory. What you'll notice is if you copy a file within a directory and paste it in the same directory, it will put a number behind that file name just to show that it's the same file, just a different copy of it. And a directory, and you may be used to having it be called a folder within Windows, is a hierarchical collection of directories and files. And we'll talk a little bit more about that as we go on. So there are really a couple different types of file systems that are used within Windows. NTFS, or New Technology File System, is the one that is most prevalent today on operating systems like Windows 10, Server 2012, and 2016. NTFS is what most of your drives will be formatted as. NTFS has been around since 1993, and as I said, it's really the most common file system for Windows. Both end user systems as well as servers that are running Windows will run the NTFS file system. There's also another kind of operating system that was really previous to NTFS, which is called File Allocation Table, or FAT. It's a more simple file system that's been really used since the 80s. And you may see different numbers associated with that FAT operating system, or excuse me, that FAT file system. And those numbers that precede the FAT or file allocation terminology refer to the number of bits used to enumerate a file system block, so FAT16 or FAT32. Mostly where you will see file allocation table file system is on removable drives. So if you have a USB drive or even a CD drive that's writable, it would typically be formatted as a FAT32 file system. And FAT32 can be used for devices that are less than 32 gigabytes in capacity. As we saw, hard drives get bigger than that. We needed a new type of file system, and that's where the NTFS came in. And now FAT is mostly used for smaller drives and smaller removable storage devices.
In this video, you will learn to describe the Windows directory structure and how Windows handles the separation of 32-bit and 64-bit applications.
So let's look at a typical Windows directory structure. And most of you who have seen Windows before have probably seen that everything is stored on normally the C drive. I don't know why it was called the C drive, but that's just what we call it. So your main hard drive is typically called your C drive. And these are the kind of standard file structure you will see on a Windows 10 device. So you'll have some folders that are hidden, and when they're hidden, that just means that they're not accessible to the end user unless you actually go in and unhide them within the control panel. So those are folders that Microsoft says, you really don't need access to those, so we're going to hide them from you. And the main one that's hidden is called perf logs. And it holds performance logs, but typically it doesn't really hold anything. It's usually empty, but it is a folder that is one of them that's in the common directory structure off your C drive. And then you have kind of the meat of what's on the C drive, which are your program files and your program files x86. So on newer operating systems that can address more memory, we went to a 64-bit operating system. Some of you may remember that when Windows first came out, it was a Windows 3.1 was actually a 16-bit operating system, and then Windows 95 became a 32-bit operating system, and we had various versions of Windows operating systems, both 32-bit and 64-bit operating systems. And the real difference between a 32-bit and a 64-bit operating system is the amount of memory that can be addressed. as applications came out that needed more memory to run, operating systems increased their bit to 64 in order to address additional memory. 32-bit operating systems can only address 4 gigabytes of memory, and for modern applications, that's just really not enough. So with Windows 2000, we started seeing operating systems that were 64-bit, and then XP and Windows 7, and then finally with Windows 10, Microsoft actually stopped releasing 32-bit operating systems, and Windows 10 is only available as a 64-bit operating system, and most of your server architectures as well are 64-bit. So, and the reason I go into that level of detail is because of those two different program files. So program files will store your 64-bit applications. If you have a 32-bit operating system, you won't have a program files x86 directory, because all of your applications will be installed in the program files directory. On a 64-bit edition of Windows or a 64-bit operating system, your 32-bit applications will be installed in program files x86, and 32-bit applications can run on a 64-bit operating system. They are just separated, so you'll see where they're installed differently. And then you will also have a folder called program data, and those are files that are accessed by computer programs regardless of what user is logged into the system. So they're really files that the applications that you run need in order to work effectively, independent of any user that might be logged on. And then you have your user directory. This is where your user profiles are stored, and each subfolder will be a different username. So as an example, all Windows operating systems will have a public folder. So this is where end users might be able to share files. So if you have multiple people logging into a system, they can put something in public and everyone would have access to that file. And then you will have, in addition to public, under the users folder, you will have each username of people who have logged onto that system, or I should say who are authorized to log onto that system. So user files are typically stored in there. You may have lots of folders under the username directory. So you would have a documents, my documents folder, you'd have a pictures folder, a music folder. Anyone who's seen a modern Windows operating system will have noticed that. And then you will also have an app data folder. This would be like your program data folder, but for application data that is specific to an end user. So if you have a custom template within, say, Microsoft Word, it would be stored under your username and then the app data folder in order to separate it from other users who may log onto the system. And then in addition to that, you'll have your Windows system directory. And this is where Windows is actually installed here. And you'll have mainly 3 folders under that: your system 32, and your syswow 64. These are file or folders that really are the core features of Windows and the Windows API. So anytime a program asks Windows to load what we call a dynamic link library file, and it doesn't specify a path, these are the folders that are searched. So this is where Windows stores all the kind of system files that are needed to run Windows and provide the graphical user interface to the end user. Your system folder stores your 16-bit DLLs, and really will be empty on 64-bit editions of Windows, but the system folder is still there on 64-bit operating systems. Your system 32 will store either 32-bit or 64-bit DLL files, and what that really will depend on whether you're on a 64-bit or 32-bit system. And then your syswow 64 will only appear on 64-bit versions of Windows and store your 32-bit DLLs. And so that's really what you'll see when you open up a common C drive on a Windows system, either an end user system or a server system. These are the folder structure that you'll commonly see on a modern Windows operating system.
In this video, you will learn to describe the Windows directory structure and how Windows handles the separation of 32-bit and 64-bit applications.
So let's look at a typical Windows directory structure. And most of you who have seen Windows before have probably seen that everything is stored on normally the C drive. I don't know why it was called the C drive, but that's just what we call it. So your main hard drive is typically called your C drive. And these are the kind of standard file structure you will see on a Windows 10 device. So you'll have some folders that are hidden, and when they're hidden, that just means that they're not accessible to the end user unless you actually go in and unhide them within the control panel. So those are folders that Microsoft says, you really don't need access to those, so we're going to hide them from you. And the main one that's hidden is called perf logs, and it holds performance logs, but typically it doesn't really hold anything. It's usually empty. But it is a folder that is one of them that's in the common directory structure off your C drive. And then you have kind of the meat of what's on the C drive, which are your program files and your program files x86. So on newer operating systems that can address more memory, we went to a 64-bit operating system. Some of you may remember that when Windows first came out, it was a Windows 3.1 was actually a 16-bit operating system, and then Windows 95 became a 32-bit operating system, and we had various versions of Windows operating systems, both 32-bit and 64-bit operating systems. And the real difference between a 32-bit and a 64-bit operating system is the amount of memory that can be addressed. As applications came out that needed more memory to run, operating systems increased their bit to 64 in order to address additional memory. 32-bit operating systems can only address 4 gigabytes of memory, and for modern applications, that's just really not enough. So with Windows 2000, we started seeing operating systems that were 64-bit, and then XP and Windows 7, and then finally with Windows 10, Microsoft actually stopped releasing 32-bit operating systems, and Windows 10 is only available as a 64-bit operating system, and most of your server architectures as well are 64-bit. So, and the reason I go into that level of detail is because of those two different program files. So program files will store your 64-bit applications. If you have a 32-bit operating system, you won't have a program files x86 directory because all of your applications will be installed in the program files directory. On a 64-bit edition of Windows or a 64-bit operating system, your 32-bit applications will be installed in program files x86. And 32-bit applications can run on a 64-bit operating system. They are just separated, so you'll see where they're installed differently. And then you also have a folder called program data, and those are files that are accessed by computer programs regardless of what user is logged into the system. So they're really files that the applications that you run need in order to work effectively, independent of any user that might be logged on. And then you have your user directory. This is where your user profiles are stored, and each subfolder will be a different username. So as an example, all Windows operating systems will have a public folder. So this is where end users might be able to share files. So if you have multiple people logging into a system, they can put something in public and everyone would have access to that file. And then you will have, in addition to public, under the users folder, you will have each username of people who have logged onto that system, or I should say who are authorized to log onto that system. So user files are typically stored in there. You may have lots of folders under the username directory. So you would have a documents, my documents folder, you'd have a pictures folder, a music folder. Anyone who's seen a modern Windows operating system will have noticed that. And then you will also have an app data folder. This would be like your program data folder, but for application data that is specific to an end user. So if you have a custom template within, say, Microsoft Word, it would be stored under your username and then the app data folder in order to separate it from other users who may log onto the system. And then in addition to that, you'll have your Windows system directory. And this is where Windows is actually installed here. And you'll have mainly 3 folders under that: your System 32, and your SysWow 64. These are file or folders that really are the core features of Windows and the Windows API. So anytime a program asks Windows to load what we call a dynamic link library file, and it doesn't specify a path, these are the folders that are searched. So this is where Windows stores all the kind of system files that are needed to run Windows and provide the graphical user interface to the end user. Your system folder stores your 16-bit DLLs and really will be empty on 64-bit editions of Windows, but the system folder is still there on 64-bit operating systems. Your System 32 will store either 32-bit or 64-bit DLL files, and what that really will depend on whether you're on a 64-bit or 32-bit system. And then your SysWow 64 will only appear on 64-bit versions of Windows and store your 32-bit DLLs. And so that's really what you'll see when you open up a common C drive on a Windows system, either an end user system or a server system. These are the folder structure that you'll commonly see on a modern Windows operating system.
In this video, you will learn to describe authentication and authorization within Windows Access Control, define Windows privileged accounts, describe the principle of least privileges.
We're going to talk about role-based access control and permissions in Windows. And Windows really approaches access control in a couple different ways, and those are really about authentication and authorization. So once a user is authenticated, the operating system itself determines what permissions the end user has to access a resource. And when we say a resource, that could be something like a file on the system, a folder, anything that's on the system. We'll talk a little bit later about Active Directory, which really moves the authentication and access control to a server side, so that once you're authenticated on a server, you have access to network resources and those kind of things. But for right now, we're just talking about local access control. And in that access control model, we have what are called users and groups, which are security principles. So principle in the context of a person, as opposed to a principle like a guiding principle or something. And those security principles have rights and permissions that inform the OS what each user and group can do. So when we're talking about the access control model, you could have a user that is an administrator, and they would have pretty much access to everything on the system. You could have a user that is a guest user, and they would have limited access, or you could have some level of access in between that, where they have access to some things but not other things. And those can also be divided into groups. So as an example, administrator is a group which can have multiple people who sign on to a system as part of that group. The security principles, meaning the user perform actions on an object. So they might save a file, they might create a file, they might delete something in a folder, those kind of things. And those are really what are being dictated by the access control and security in the Windows operating system. Resources that are shared by multiple security principles or multiple users use what we call ACLs, or access control lists, to assign permissions, and they enforce access control in a couple of different ways. They deny access to unauthorized users and groups. So if I have a folder that is only available to the administrator group, only those folks are going to be able to get in there and do things to it, and other people who sign onto the system will not have access to it. They also set limits on the access that is provided to authorized users. So I can really control what kind of access any user or group has within the system, whether it be the times that they can log in, what they can see when they log in. That all can be controlled based on the permissions that are set within the operating system. So now let's talk about privileged accounts. Privileged accounts are accounts that have direct or indirect access to all of the assets in an IT organization. As I said before, we're going to talk a little bit more about Active Directory, which is really how that's controlled at an administrative level, so that I can control all the machines that log into my network, and I can control all the folks that log into those machines. But I can also have administrators that will control only their system. So administrators configure Windows operating system to manage control for multiple roles and uses. And we go by the concept of the principle of least privileges. So, and as Wikipedia says, the principle means giving a user account or process only privileges which are essential to perform their intended function. And this is really important when we talk about security. One of the main concepts of IT security is access control, and making sure that people who don't have access to privileged information, or let me say it a different way, making sure that people who need access to privileged information, such as HR records or customer data or whatever it is, depending on the industry where you're working in, those are the only people that can access that data. And it's really important because with user privacy laws, and we have regulations like HIPAA and GDPR in Europe, it's really important that only people who have a need for particular data are able to see that data. In addition to that, it also provides better system stability. So not only are you protecting the data, you're also making the operating system and the hardware itself more secure, because you're not giving people access to things that they don't need to, like installing applications, installing drivers, anything that could potentially harm the system in the environment. And this leads to better system stability, or I should say better system security, excuse me, because you are controlling not only what folks have access to and what they can do on the system. That gives a much better secure and more stable system, because there is less variance in the environment. And this leads to easier deployments as well, meaning savings of time and money for the environment, because you are not have a tremendous amount of variance and everybody doesn't have access to do things on their own system. So it's all controlled from a central location and provides much more control from an administrative from an administrative perspective, which leads to the three things we talked about: better system stability, better system security, and ease of deployment as well. So when you talk about access control, there's really four main concepts that we're talking about. We're talking about permissions, we're talking about ownership of objects, the inheritance of those permissions, user rights, and what we call object auditing. And we'll go into a little bit more detail on each of these things.
In this video, you will learn to describe Active Directory, describe Active Directory features.
Okay, so now we're going to talk about Active Directory. And Active Directory is really the predominant directory system that you will see that most enterprises use. If they don't have a homegrown directory, they're probably using Active Directory to control users and permissions and those kind of things. Active Directory, or AD, is really a system that stores information about things on the network and makes that information easy for administrators to and users to find. So it will control things like your network folders, network printers, anything that a user may need to be able to get to do their job can be controlled by AD. And AD stores those the information about those resources as well as permissions and controls the permissions as to what you can get to. What we're seeing now is many organizations, IBM included, is moving to what we call Azure Active Directory. So instead of having physical servers on site, they're moving to a cloud-based directory service. And Azure Active Directory is Microsoft's cloud-based directory service. So when I log into my laptop, it's actually logging into an Active Directory that sits on Microsoft's cloud and provides permissions that have been set by the AD administrators within IBM that are logging into their AD console through the cloud. So there's nothing on-prem for IBM within Active Directory, and many organizations are moving to that because it's more convenient. The objects that are included in Active Directory are things like servers, volumes. So when we say volumes, that's a driver, a folder, printers, and network and computer accounts. So Active Directory will have both a computer account as well as a network account. So really what this gives Active Directory the ability to do is control both of those things. So even if I have an AD account, if the computer that I am logging into does not belong to AD, does not have an entry into the AD, I will not be able to log into Active Directory, and vice versa. So if I have a computer account that is on AD but not a user account, obviously I won't be able to log into AD, and I won't be able to log into that computer either because that computer belongs to Active Directory. The nice thing about Active Directory security is really integrated into it through authentication. So when I type in my password or use my fingerprint, I'm accessing the Active Directory, which tells resource that I'm logging into, in this case a laptop or a desktop. It tells that machine what things I have access to. So can I get to this server? Can I get to this directory? Can I get to this printer? And that's all done through that policy-based administration, which is part of Active Directory and which is controlled by your Active Directory administrator. There are some features of Active Directory that might be interesting to discuss, and really the features of Active Directory and what Active Directory really is a set of rules or a schema, and that really controls what end users have access to. So the rules are these things that are controlled by the AD administrator, which tells groups or users what they can get to. It has multiple hundreds, frankly, of settings that can really provide granular control of what users can do in an AD environment. It also controls things like your password policy, your password complexity. Anything security related is controlled through Active Directory. It also has a global catalog. So as a user, I can look at what things are in the global catalog, and that will tell me if I have access to it, what other users, what other machines, what servers I have access to, what printers might be available for me to print to, and those kind of things. It also has a query mechanism, so you can go in and search Active Directory for things like servers and printers and other resources that you might need. And then it also has a replication service. So if you have a large Active Directory, or if you want to protect your Active Directory, that replication can go to multiple servers. So you may have AD servers placed geographically within your environment to spread out the load between AD servers. Now, as I mentioned before, many organizations are moving to a cloud-based AD, Azure AD, and then that requirement for replication goes away because it's all done on the back end by Microsoft.
In this video, you will learn to describe and differentiate Active Directory account types, discuss security considerations for Windows account setup.
Okay, so now let's talk about Active Directory accounts and security considerations around Active Directory accounts. So there are several different Active Directory accounts, and they are similar to your accounts that we talked about earlier that are local accounts. So you have your administrator account, you have your guest account, and you have your help assistant account, and then a fourth one called your KRB target account or KRB TGT account. The administrator account and guest account are very similar to the local accounts that would just control access to things in the environment. Help assistant account is an account that may be logged into if someone needs to remotely help your PC, and the KRB TGT account is really an account that is not one that is logged into. It's more of a system account that may be used in the environment, but it's not something that end users are really going to log into. Also, within Active Directory, Active Directory allows for settings of local accounts within the Active Directory. So when I, as an AD administrator, provide someone with a PC, what happens is, since that PC belongs to my Active Directory, those default local accounts will be managed in the Active Directory. So even if I'm an administrator, or I should say if I'm a user in Active Directory, I may not have administrator rights on my own machine because that's all controlled via Active Directory for my local machine. So an end user may not have full control over their own PC once it resides in Active Directory, and in fact most end users don't have full control because we want to frankly take as much control away from them as possible so that they can't do things that could be harmful to the environment. And it also will manage those default local accounts in Active Directory as well. So if I want to turn off the guest account, I can do that. If I want to add another account on a system, I can do that as well. And I can do all those things remotely from Active Directory. The other thing that Active Directory accounts do is manage domain controllers. So obviously you would have to be an AD admin to do that, but that's someone who would control login credentials and how people log into the system. So let's talk a little bit about protecting domain accounts and how you do that. And again, when we're talking about domain accounts, those are things that accounts that can access things on the network. And one of the things you want to do is separate your administrator accounts from your user accounts. So they're going to be, in fact, most people are going to log in as a standard user and not as what we call a privileged account. So a privileged account is administrator accounts that there are various levels of administrator accounts. So if we talk about a privileged account, you may have multiple levels of that. Even though someone belongs to an administrator group, they may have different administrative levels within that group. So as an example, you have three different levels of administrator accounts that you may want to do in your environment. So at a minimum, you want to create separate accounts for domain administrators, enterprise administrators, or any other administrator that it needs to have access to systems and resources in AD. That's the bare minimum you want to do. So you have administrative accounts that have various levels of access. Better is to create separate accounts for administrators that may have more reduced administrative rights. So I may have access to particular workstations or particular resources in the environment and not access to all the resources in the environment. And those are usually segregated by what we call OU. So within Active Directory, you will have OUs or organizational units. So I may have administrator access to one OU, but not another one. So think of an OU as a department, and that's making it much more simplistic than it is, but you could have a marketing OU, you could have a sales OU. OUs can be set up for a variety of different functions within the organizations, but certainly when you're looking at protecting the environment, having administrators that don't have access to all your OUs is better than just having administrative accounts. And then ideally, if you're talking from a security perspective, you want to have multiple accounts separate accounts for an administrator who has multiple job responsibilities. When I go into organizations and talk to customers or see how customers do things, many customers have accounts that have, or they should say many customers will have multiple accounts in their environment. So they may have an administrative account that has access to one thing, and then they'll have an administrative account that has access to other things, and this just protects the environment and makes things more secure. And those different accounts will have different what we call trust levels within the environment to make things more secure. And then, of course, you have your standard user accounts, and these are just your standard business user, such as email, web browsing, and using particular what we call line of business applications. So if you need to use an HR application or something else, your account may have access to that, but not be able to control things on your PC. And those are the majority of end users will just be standard users. Okay, so another way or a discussion around protecting your domain accounts and restricting those domain accounts is to create workstation hosts without internet and email access. So these are for folks who may need to manage job responsibilities that require administrative rights from a particular workstation, and they may not have they may not have physical access to servers. So, I may need to log into a server, but in order to protect that server, what customers might do is, or what folks might do is create a terminal or a PC, or have a PC there that it can only access particular things on the network. So access particular servers, but not be able to access the internet as a whole. And that way I'm protecting those particular environments because, or those particular servers, those particular AD resources, because the computer that I'm using to access them does not have internet access. So I can't accidentally infect those servers by something when I'm, surfing a website and inadvertently move something to one of those servers. So, and that's really a bare minimum. So the minimum is to build those administrative workstations that don't have internet access, including things like web browsing and email. And then even better, we want to make sure that administrators on that system can't be part of the local administrator group so that they can manage the servers that we talked about, but they can't manage the local system they're logging into in order to bypass those restrictions. Because remember, once you're an administrator on a local system, you have full control over it and you can change settings. So we want people to have access to the servers that they're managing, but not be able to bypass the protections that we turn on. And then ideally, you can restrict workstations from having any network connectivity except for the servers and domain controllers that the administrator accounts are used to manage. Now, practically, I've seen very few organizations that do anything that we would categorize as better. I've never seen in organizations where they have to log into a target or a specific workstation that only has access to servers and domain controllers. Most organizations will allow people to log in from their local system, and they trust those people who manage their environments to not do dumb things and put their environment at risk. But these are just some of the things that we recommend as being good security practices. Certainly in high security environments like government or other industries that require that level of security, these are probably things that you want to think about. Okay, so one of the next step in protecting your sensitive domain account is to really restrict the administrator login access to servers. So, and what we mean by this is you're going to restrict administrators from using their admin accounts to sign into what we call lower trust servers and workstations. So let me put that in real-world context. So if I'm a domain admin, I'm not going to log into my local system to check my email and to surf the web and to write my resume as my domain admin. So that's what I talked about before about having multiple accounts. You'll have users that have their standard user account, and then they'll have their domain admin account. And that's really the best practice, is to not have those people log in with their domain admin account. When I come into work, I'm going to log in as my standard user account, and only when I need to use my domain admin account will I use that account. And so when I'm logging into the domain controller, when I'm logging into a server to do some work on it, or to do anything like that, I would then and only then would I log in with my domain admin credentials. And there's some guidelines that are recommended to do that. And the first one at a bare minimum is to restrict domain admins from having access to servers and workstations. So what we mean by this is computers that are not in particular OUs that are controlled by Active Directory, they're not able to log into. So it provides a layer of protection there to do that. And then even better than that is to restrict domain administrators from non-domain controller servers and workstations. So anyone who's a AD admin or a domain admin, they won't be able to log into things that are not part of the domain as well, and that provides even more protection. And then we want to, the ideal thing is if you have server administrators, do not allow them to sign into particular workstations. So if I'm a server admin and I control Windows servers, I don't want to be able to log into workstations other than my own, or the organization doesn't want me to be able to log into workstations other than my own. And the only reason I would log into my workstation is just to do my day-to-day job, and that's really the ideal security for domain accounts. Okay, so let's talk about the fourth thing we can do to restrict and protect sensitive domain accounts. So one of the things that we want to do is disable the account delegation right for administrator accounts. So what that means is because Active Directory accounts, user accounts, can be trusted for delegation, meaning I can delegate someone to do another account to do something, that really gives the ability to impersonate an account that authenticates to other resources on the network. And in order to avoid that, you can configure sensitive accounts within Active Directory to not be delegated, meaning that I can't delegate that to a different account. I have to only log in with that account, and that is the only way I can do things in the environment, and that prevents things from potentially impersonating other accounts that would cause an issue. And you only need to do this with sensitive resources. So, your domain controllers, any servers that you deem as sensitive, that would require that you turn off delegation. But for normal servers that people need to log into, delegation is fine.
In this video, you will learn to define types of Active Directory groups, describe an overview of features and tools within the Windows Administration Center.
We're going to talk now about server management with the Windows Admin Center and leveraging Active Directory groups or security groups to manage accounts and to manage servers. For Active Directory, there really are two types of administrative responsibilities: service administrators and then data administrators. So service administrators are managing things in the environment, such as what I have access to, what I can do on my device or with resources on the network. And then there are what we call data administrators, who are actually managing access to the data in the environment. So things like customer records or employee records or any kind of sensitive information that the average end user doesn't need access to. And there are two types of groups within Active Directory by which we manage those. So those are distribution groups, and those are used to create email distribution lists, and then security groups, and those are used to assign permissions to shared resources. You know, everybody in Active Directory is going to be part of a distribution group because most organizations are going to control their email through Active Directory. Sign into AD, and that's how your email is delivered to that particular machine. You know, I log into the machine, launch, as an example, Microsoft Outlook, and then because I've logged into the machine as my AD account, the machine knows, hey, this is this person. Here's the email that is assigned to that person, and so my email is delivered to me through Outlook, through Active Directory, essentially. And then there are security groups which are assigned permissions to shared resources. And when we say that they're used to assign, if I'm part of a security group, that means that I have access to particular shared resources. The AD administrator is the person who actually assigns the permission, but the security group is what controls the permission. So through a security group, I have access to particular servers, particular printers, whatever is part of that security group in the environment. And then let's talk about scope around those groups. So any group that is created within Active Directory is characterized by a scope, which means the extent that that group is a part of the domain and what they can do in the domain. And there are three scopes that are defined by Active Directory: universal, global, and domain local. So, and really, this level of detail is more than most people would need to know about Active Directory. We're really getting into the kind of the minutia here, but just things that are interesting to know about Active Directory. So when you first create an Active Directory domain, or when an organization creates an Active Directory domain, they have these default groups, such as the domain admin groups, and that's a security group that controls the domain, basically. And those predefined groups help control access of those shared resources and those specific domain-wide administrative controls within Active Directory. The Windows Admin Center is new with Windows Server 2016. And that is a browser-based management tool that you can manage your Windows servers. It gives you really full control over all aspects of the server infrastructure, and it's really useful in managing servers on private networks because they're still connected to your domain, but they may not be connected to the Internet. Many organizations will not connect their servers to the Internet because they worry about breaches and those kind of things. So the Windows Admin Center allows you to control those servers remotely, even if they're not connected to the Internet. And that is really one of the ways that organizations manage those servers is through the Windows Admin Center. They may have other tools as well, but that's one of the main ways that servers are managed through a Windows environment and an AD environment.
In this video, you will learn to define Kerberos authentication, describe the use of Windows Server logs.
So we're going to talk about security and compliance and spend a little bit of time on that within the context of the Windows operating system. And one of the things that we probably should become familiar with what's called Kerberos authentication. And it's an authentication protocol that it's used to verify the identity of a user or a host. And Windows uses it mostly around AD. So when someone logs into a system that is connected via AD, most AD systems will leverage Kerberos as the authentication protocol that secures the AD or the Active Directory in order to authenticate that end user or that resource on the AD. What's called the Kerberos Key Distribution Center, it's integrated with part of Active Directory, other Windows Server Security Services, and it uses the domain Active Directory Services database. You really don't need to get to that level of detail. What is really important is to understand that Kerberos is the predominant mechanism which is used within Windows for authentication and for securing the Active Directory environment. That's been around for a long time. The key benefits really of Kerberos include things like delegated authentication. So authentication can be delegated to different resources in the Active Directory forest between other resources and other users within the same AD. Single sign-on capability, so when I sign on to AD, anything that leverages that AD sign-on, I've automatically signed on to as well, so I don't need to then sign on multiple times to access resources within that Active Directory environment, which makes things a lot easier and a lot more convenient for the end user, but still maintains security. And then interoperability. So when I'm leveraging Kerberos, it really doesn't matter any of the characteristics of the resource that I'm going to, because as long as they are part of AD and I've authenticated to AD, I can get to those resources within the AD, which makes things easier for the end user as well. And then it's more efficient to have that authentication built in. So by leveraging Kerberos, which is built into AD, we don't have to have a separate authentication service. We don't have to have anything like that. Although that being said, many organizations are looking at two-factor authentication or have already enabled two-factor authentication within their environment to provide another layer of security. And two-factor authentication, just real quickly, is leveraging, say, your AD password and then maybe a third-party authentication service like Google Authenticator, or Microsoft has an Authenticator, or IBM has a identity and access management solution that provides those kind of capabilities to make things more secure. But for the most part, AD leverages that Kerberos and that single-factor authentication. And then the final thing is mutual authentication. So again, providing that ability to log onto multiple things with just leveraging that same username and password that's built into Active Directory. Now we're going to switch topics real quick and talk about Windows logs, Windows server logs. And server logs are important when you're talking about security, when you're talking about managing Windows servers, because that's really where all your information is held within a Windows environment. Logs are records of events that happen in the computer, and those logs, and server logs are no different than logs that are held on a desktop or laptop. Just any Windows system, or frankly any system, regardless of the OS, is going to have logs. We're just talking about it in the Windows context right now, but they are events that happen either by a person or a running process. And the purpose of those is for you to track what happened and to troubleshoot problems, but also it's to help to investigate security events. So when we talk to customers about how to manage their environment, logging is a very important component of that. And one of the things that we do is help customers aggregate those logs and analyze those logs to figure out what events may have occurred that led to a potential breach or a security event or anything that is out of the norm that needs to be investigated. From a Windows perspective, the most common locations for those logs is what's called the Windows event logs. And it contains logs from the operating system and lots of other Windows applications that may be run on that server, such as SQL Server or IIS, Internet Information Server, which is Microsoft's web hosting application. And they use what's called a structured data format, and it really makes them easy to search and analyze for. Other logs may be written in what's called text format, so you can go in and actually just read those manually if you want to. But many organizations will leverage a log aggregator to make sure that you can see things easily. So if we look at this slide, this is kind of an example of what you would see with the Windows Server log, and these are contained in the Windows Event Viewer. The Windows Event Viewer lets you look at, in a single place, the Windows event log and search or filter for particular types of logs that you might be curious about. And really, when we talk about logging, we're talking about it in a broader context of just one machine. We're talking about it from a perspective of an organization might have hundreds or even thousands of machines that they need to monitor. And if you think about that, it becomes very quickly a challenge as to how customers will do that or how organizations will do that. And so many organizations look at a tool like a log aggregator, or even what's called a SIM, a security incident and event management system, that will gather all those logs from all the hundreds or thousands of the machines that they manage and pull them all into one place. And then that log aggregator or SIM will analyze those logs automatically and point out anomalies so that they can then be investigated by security folks. And that's really one of the cruxes of what cybersecurity is looking at systems, looking at the logs on those systems, and then getting automation to aggregate those logs as well as analyze those logs to look for events that may need further investigation.
In this video, you will learn to describe auditing and access control for Windows Server.
So another facet of cybersecurity is around auditing. And when we talk about auditing, it's establishing a policy and looking at monitoring the creation or modification of objects to track potential security problems. When we talk about monitoring objects, we're talking about typically files or folders, and in this context on a Windows system. And it does really a couple things. It helps ensure user accountability, and it can help provide evidence in the event of a security breach. So let's dig into that a little bit. When we talk about user accountability, 50% or about 50% of cybersecurity events are internal, meaning that it was caused by someone within the organization. Now, that doesn't mean that every single security event that is internal is caused by a bad actor. It could very well be that someone clicked on a link accidentally or didn't know any better. So it's user, for lack of a better term, ignorance that may cause a lot of security events, because cybersecurity bad actors are getting very sophisticated in what they can do. You know, you'll get emails that say click on this link, that'll take you somewhere that downloads a file to your computer, and then hell breaks loose within the environment. So looking at things on a machine or on an endpoint or a server for monitoring that auditing of those objects is really, really important, because when you look at a cybersecurity event, it is mostly how they start mostly is a file is either dropped onto a system or is modified in order to start a chain of events that will cause some problems in the environment, some malicious activity in the environment. And from a Windows perspective, there are 9 kinds of events that you can audit. And those events are in the security log, which we talked about a little bit earlier, which is parsed into the Windows event log, or I should say the Windows event viewer. And that's what most people will monitor in their Windows environment to check on these kind of events. And we talked a little bit earlier about how folks will use an event parser or a log parser or a SIM to look at those events. So the 9 kinds of events you can talk on are account log on events. So this is somebody logging into a system and logging in remotely is really what we want to make sure that we're auditing, because if someone if you look into a system and see that someone has tried to log into it 1,000 times within a second, you know, you're maybe an example of a brute force attack of someone just trying to check random passwords to see if they can log into the environment. You can also look at account management. So this can be audited when someone has changed an account name, enabled or disabled an account, or created or deleted an account, or changed a password. So if you notice that there are a ton of accounts being created in a very short amount of time, that may be something that has to be investigated from an account management perspective. And then directory service access. So when someone accesses an Active Directory service object, that has its own access control list as well. So if someone is trying to get into a particular system in the environment, like I said, multiple times in a very short amount of time, that might be an example of an event that needs to be investigated. And there are other events as well, log-on events. So when someone is trying to log on or off of a computer, either while physically at the computer or trying to log on over a network, and then again looking at how often that is occurring, if it's the same person, where that log-on is being attempted from, because with seeing the IP address, we can 99% of the time determine where that person is, at least within a specific geography. Obviously, we can't get to the exact desk where they are, but you can know, this is from a cafe in Somalia trying to log into a system that's located in Kentucky. We probably want to investigate that. We can also look at object access. So if someone has used a file, a folder, or a printer, or another object, and you can also, so anything that can be accessed within Active Directory can be audited to see who accessed it and when and for how long. You can also audit policy change. So if attempts to change the local security policies and to change user rights assignments, those will be tracked within Windows and can be audited. So if I am a local admin on my machine and I go in and try to change local security policy to disable the password or to make the password less secure, that will all be tracked by Windows, and an organization can audit that to make sure that it's not being abused. And privileged use, so when someone performs a user right, that will also be tracked, and also track processes on the endpoint, such as when a program is activated or a process exit occurs. So as an example, if I'm an admin on my machine and I go into the task manager and stop the AV process because it's slowing down my machine, or I should say because I feel like it's slowing down my machine, that will be tracked within Security Center, and then I can audit that and ask, and investigate that. Why is someone turning off their AV, and take appropriate action? And that's just an example of the kind of things that could be audited within process tracking. And then system events. So when someone shuts down or restarts the computer, or more importantly, when an application or a program or even a process tries to do something that it doesn't have permission to do. And this could be an example of a security event where someone is trying to do something malicious in the environment. They're trying to have a process do something to access a remote computer or access a remote database or anything that it doesn't have the rights to do. It's the purpose of doing something malicious in the environment.
In this video, you will learn to describe why organizations use the Linux operating system.
Hello everyone, my name is Alex Campos. I'm CM Administrator in MSS IBM Security, and today we are going to start with the Linux course for beginners. So, Linux is a multi-user, multitasking operating system which provides a number of facilities including management of software, resources, directories and file systems, and the loading and execution of programs. The Unix operating system got started in 1969 at Bell Laboratories and was written in assembly language. Then, in 1973, Thomson and Ritchie succeeded in rewriting Unix in the new language that was C. In September of 1991, Linus Torvalds released the first version of what it was to become the Linux kernel. Torvalds greatly enhanced the open source community by releasing his license under the GNU license. The GNU license is a widely used for free software license which guarantees the end users the freedom to run, study, share, and modify the software. Now, why Linux? Well, the system is flexible enough to allow users to build applications with a wide variety of support tools such as compilers, scientific libraries, debuggers, and a network monitors. Linux has also four essential properties which make it an excellent operating system for science community. Performance, functionality, flexibility, and portability. Performance of the operating system can be optimized for a specific task, such as running small portable devices or large supercomputers. Now, how does the Linux work? Well, there are two major components of Linux, the kernel and the shell. The kernel is the core of the Linux operating system, which includes the processes and interfaces directly with the hardware. It manages the system and users, processes, devices, and files, and memory. The shell is an interface to the kernel. Users input commands through the shell, and the kernel receives the tasks from the shell and performs them. The shell tends to do four jobs repeatedly. 1. Display the prompt. 2. Read the command. 3. Process and give in the command. And 4. Execute the command.
In this video, you will learn to describe the Linux directory structure.
Next, we're going to discuss how Linux and the file systems was designed or is designed. Let's talk first about files and directories. Files is a basic unit of storage for data. This unit is basically stored or pretty much stored on a physical media such as hard drive, a thumb drive, or anything that it's designed to store information. It's represented by a dash, and we'll discuss this later on. A directory, on the other hand, it's in a special type of file. A directory has information about other files, so it's like a container for files, and it's the equivalent of folders in Windows. In Linux, it's represented by a letter D in the command line interface. In the screenshot below, or the image below, you will see the highlighted directory that are on the first letters on your left, I'm sorry. You will see that it starts with the D. That indicates that specific item right there, it's a directory. But you will see just above that not a copy.txt. It starts with the dash, so that indicates that specifically is a file. Linux and the directory structure is a lot different than what we're used to in Windows. Everything starts with the slash, also called the root, and everything else it's just quote unquote attached to the slash partition or the root partition. The slash partition, also called root, it's where every single file and directory starts from. Only the root user has write privileges under this directory, and that's supposed to be like that for security reasons. The slash partition, it's not the same as the slash root. The slash root is basically the home directory of the user root. We'll discuss home directories in a little bit. The slash bin directory, it contains binary executables, basically. Common Linux commands are found here, and we have a list there: ps, ls, ping, grep, cp, mv. We'll discuss a little bit more about basic commands in Linux in a couple of slides. The slash sbin, it contains executable binaries as well, but they're more related to system maintenance tasks like IP tables, like the reboot command, the fdisk, or the ifconfig, for example. The slash etc, it's where most of the times you will find configuration files for all the programs installed. If we have a Linux server and we install Apache on that server, for the configuration of that specific service, you will go to /etc/Apache, and you will find all the configuration files on that directory for specific applications. The /var, it's in a specific partition designed to hold files that grow or change constantly. It's referred as variable files. And a perfect example for these are logs. They're usually found under /var/log. So all the applications, or most of the applications that you will find out there, will create their logs under under /var/log. The /tmp partition, it contains temporary files. So anything that you store under /tmp will get deleted when the system reboots. This is not meant to hold files like any other partition will do. Anything that is stored under /tmp, whenever the system reboots, will get deleted. The /home partition, it's the home directory for all the users. So whenever a user is created and it creates a home directory, you will find it under /home. This is designed to store personal files for each individual user. And this specific partition will only have privileges for these specific users. So let's say I created a user called Warren. That will be on the home directory for that user will be under /home/Warren, and only Warren will be able to edit or read files from that specific directory. Another important partition is the /boot partition. It contains bootloader files. This partition is specifically used during boot time.
In this video, you will learn to describe the run levels included in Linux.
Now we're going to talk about run levels. Well, what is a run level? When a Linux system boots, it launches the init processes. Init is responsible for launching the other processes on the system. For example, when you start on your Linux computer, the kernel starts init, and the init executes the startup scripts to start your hardware, bring up the networking, and start your graphical desktop. However, there isn't just one single set of startup scripts init executes. There are multiple run levels with their own startup scripts. For example, one run level may bring up networking and launch the graphical desktop, while another run level may leave the networking disabled and skip the graphical desktop. This means you can drop from graphical desktop mode to the text console mode without networking, with a single command, without manually starting and stopping different services. So as you can see in these slides, the run levels are represented by some numbers, where 0 will shoot down this system and shoot down all the services. The run level 1 is a single user mode, and the system boots into the super user mode without starting daemons or networking, and it is basically used for booting into a recovery or diagnosis environment. The run levels 5, 4, 3, and 2 are basically the same. It provides full multi-user mode with networking and graphical login, and the run level 6, it's used for reboot. So basically, I'm going to show here in my virtual machine. I'm going to be logging here, and so this is my virtual machine, and as you can see, I'm going to be running the run level 6. You can use reboot or just init and then the run level number. In this case, I'm going to be using 6 to reboot my system. So as you can see, I'm rebooting my system.
In this video, you will learn to describe the common shell choices within Linux.
Now we have the different shells here, but what is a shell? Well, the shell is a program that takes commands from the keyboard and gives them to the operating system to perform. In the old days, it was the only user interface available on Linux operating system, but nowadays we have graphical user interfaces like the GUI, in addition to the command line interfaces such as the shell. We have here two shells. That is the bash, which is the most common default shell for user accounts, and we have the sh. It is not often used in Linux, but it points to the bash shell or other shells as well. Part of that, we also include tch shell. The tch, this shell is based on the earlier C shell. It was fairly popular, but not major Linux distributions take it as default shell. Then we have the CSH, that is the original C shell, but it isn't used much on Linux. But if a user is familiar with CSH and TCSH, takes a good substitute. It is basically used for programs based on C language. Then we have the corn shell, that is known also as key SH, that was designed to take the best features of the Burning shell and the C shell and extend them. So it has a small but dedicated following among Linux users. Then we have the Z shell, that takes shell evolution further than the corn shell, incorporating features from the earlier shells and adding still more.
In this video, you will learn to describe internal versus external Linux commands.
We are going to talk about basic Linux commands. In Linux distributions, internal commands built into the shell program and are shell dependent, also called built-in commands, and determining if a command is built-in command by using the type command. So if you use the command type and then the command that you want to check, you will see a message. If you see shell built-in, it just means that it is an internal command. Otherwise, it will be an external command. So in conclusion, internal commands are commands that are already loaded in the system, and they will be executed at any time the system requires the command. Now we have the external commands. That are commands that the system offers, are totally shell independent, and usually can be found in any Linux distribution. And also they are mostly reside in the /bin and usr/bin as well. Now, before we continue with the external commands, there are some tricks that we can use in the CLI. For example, we can use the tab key in order to fill the name, and also we can use Control A or Control E to move the cursor to a start or end to the file. So, for example, if we can see here in my virtual machine, I have here some files under Home, A Campus C, Books. I have some books here, Math Test, and this is my test. As you can see, this is a long name. So if we want to see the information that is in this book, we can use tab to save some time. So I want to see the information that is under this file that is located under Home. If I just type HO and then tab, it will just fill the entire path. For example, if I can continue with A camp and then tab, it will fill up the rest of the name. See, so we can use the tab key in order to save some time and type very quick as well. Also, let's suppose that we made a mistake and we just want to go to the top. So we can just click Control A and we will be on the top here, and we can do the changes. Or we can just go back to the end of the line with Control E. So this is basically some tricks that we have here. Also, we can use history to see what commands we already ran. For example, if I just click history here, we will be able to see all the commands that we ran already. So we just can take one and run it again. Or we can just use this to investigate which commands were run during an operation system. Also, we can use up and down arrow to see the commands that we ran. So we can save some time here as well. Also, we have demand command that is used for the manual to see what a specific command do. For example, I want to see what the ls command do. So basically, we just do man and ls, and it will provide all the information about this command and what are the flags that we can use with this command as well.
In this video, you will learn to define basic Linux commands and their uses.
Now we're going to start with basic Linux commands that we can use on different distributions in Linux. We have the uname that will show what operating system is being run. For example, as we can see here, if we run the uname command, we will be able to see that we are running Linux. But if we want to have some more details, we can also add a flag -a, and it will provide additional information like the current Linux kernel being used, system host name, and the date as well. Also, we have the cd command that is used to go to the different directories. So for example, let's see this picture here, where we can see that we have a home and different directories like Alex, Jack, Eric, and those files also have more files in there. So let's suppose that we want to go to Alex. So we are in home. As this example, we have in home. So we just need to add the cd and the name of the next directory, and we will be able to go to Alex. If we are in home and we want to go to test, we just need to add cd, then the name of the next directory, that is Jack, and then the next directory name, that is test. So in this way, using cd, we can just move from different directories and subdirectories. But what about if we are in test and we want to go back to Jack? So we just need to go to cd space and 2 points, and it will return back to the previous folder. So in this case, we are in Alex, home Alex, and we are going to go back to home. So we just need to type cd space point, and we will be back to home again. But sometimes we don't really know where we are. So there is a specific command that we can use to display the information of the path that we are. So in this case, let's suppose that we don't know where we are. So we just need to type pwd, and it will display the path where we are located. In this case, we are in home, Jack, test. So using pwd will display the path where you are located. Then we have the tar command that is used to create a new archive file. If we want to create a new archive file, we just need to type tar and the flags that will tell us to create the archive file. Then we just need to add the name of the tar and the directory where we want to create that archive file. If we want to extract that information, we just need to type the tar command and also the flags that will indicate that we want to extract the information on that file. If you just want to see what information is in there, we just need to add the following flags that will be TVF and the name of the tar as well. Then we have the grep. This command is used for searches, for specific searches. If we want to print the match line along the with the 3 lines after it, we just need to use grep. Also, I'm going to show you here really quick with my virtual machine how we can use the grep. So in this example, let's suppose that we are under Home A Campus books, and we have the following books here: car list, match test, math test, and this is my test. So under the car list, we have this information. This is the book. This is the information that we have under this file. And we want to, let's suppose that we have a lot of more names here with dates. It is a big list. So we want to find out all the information about BMW. So using grep, we can do that. So grep-i BMW and the name of the file that we are looking for, it will display the information for all BMW. Also, if we want to look for all the files that we have, we can just use grep-r BMW, and we'll display all the information on all those files as well. Then we have the find command that is basically similar to the grep command, but it will find files with a specific name. So basically you just need to use the command find, then -e name and the name that the file that you're looking for, and it will display the path where it is located. So also can use find to find a specific file with the md5, or maybe you can use the find to find out a file with the extension, or also you can find empty files in a home directory as well. Then we have the ls command that lists all the directories contents of the files and directories and display file size in human readable format. Also we have the ls-ltr that is basically the same, but it will display more information like the last modified time and also the permissions that that specific file has. It will be displayed in a reverse order. Then we have the gzip that is used to compress files. The command is gzip and then the name of the file that you want to compress. Also, you can uncompress the file by using a flag that is the -d and the name of the, of course, the name of the file that is already compressed. Here's an example. I just ran ls to see all the files that I have under books, and then I just zip the car list file. As you can see here, it just added an extension that is gz that represent a compressed file. Then we have the unzip command that is used to extract all the information that is on a compressed file. So we just need to use unzip and then the name of the zip file that is compressed, and we will be getting the information from that specific file. Also, we can just we just can see the information that is on that compressed file without unzipping the file. So we just need to use unzip, then -l and the name of the zip file. Then we have the shutdown command that is used to shut down the server immediately. For example, we have shutdown-h now that it will be power off immediately the server. but maybe we just want to shut down the device, but not yet, or we just want to shut down the server in 10 minutes or 20 minutes. In that case, we just need to use shutdown dash h plus 10. That will represent 10 minutes, 20 minutes, or maybe you need to restore the server in 1 hour and 30 minutes. So you just need to convert 1 hour and 30 minutes in minutes here, and you will be restarting the server in that time. If you want to shut down the device but then reboot it, we just need to use shutdown dash R. That will be rebooting the server. And if you want to force to check the file system during the reboot, we just need to add the flags dash F R. So it will be will force to check the file system during the reboot in the shutdown command. Any difference between shutdown dash R reboot and init6? In other distros there was, but in newer distros they do the same internal process. So basically you can use shutdown dash R reboot or init6 and it will be doing the same. That is rebooting or shut down the device.
In this video, you will learn to define basic Linux commands and their uses.
Then we have the FTP. Both FTP and secure FTP have similar commands to connect to a remote server and download multiple files. So if you want to connect to a remote server, you just need to use the FTP and the IP of or host name of that remote server, and you can then start downloading the information that you want to extract from that device. Then we have the PS command that is used for display information about the processes that are running in the system. So if you wanna see what is the process that is running for a specific service, you just need to use the ps-ef on more, pipe more. Or to view the current running process in a tree structure, you can use H option like ps-efh pipe more. Also, you can just use ps and it will display all the IDs of the different processes, and you just need to use ps then the ID of the process, and you will see all that information as well. Then we have the free command that is used to display all the information about the memory available in the system. So just running free, you will see all the total memory that your system has, also the free memory. But sometimes it's difficult to understand or interpret what are those values. So we can just add -G that represents the gigabytes, and you will see all this information in gigabytes. So if you want to quickly check how many gigabytes, you just need to run free-G. Also, you can use A if you want to see in kilobytes, or M if you want to see in megabytes as well. So the free command will display all the information about the memory used in your system. Then we have the top command that displays the top processes in the system. So if you want to see the information displayed by top command, you will see all the processes that are running on top of my system. Also, you will be able to see the CPU usage and memory as well. Now, if you want to display only the processes that belongs to a particular user, you can use -U option, and it will display the information of the processes that are running on that specific user. For example, if we run the same command here, of course, it will be showing the same information since I'm using the same user. But if we have a big environment where we have a lot of users, we can just monitor for a specific user by using this command as well. Now we have the df command that will display the disk space usage in our environment. If we use the -k, it will display the output in bytes. But if we use the -h, it will display the output in human readable form. So for example, in our virtual machine, we have here our partition in the f-h. We'll see all the information about the disk space usage in our environment. If we use the flag -t, it will display what type of file system is in use for every partition we have in our Linux distribution as well. Then we have the kill command that is used to end a process that is running on our environment. So if you want to kill a process, it is really important to know first the ID of the process that is running. So using the ps-ef will display the ID and the process as well. So you just need to use kill-9 space and the ID of the process that you want to kill. It's really important to be care of this, since as soon as you kill the process, it won't come back again. For example, in this case we are trying to find out an ID for all the files that belongs to, or processes that belong to Beam. So we're just running the ps space-ef, and we're doing a grep for Beam to find out. In this case, it displays 7243. That is the ID of the process that we want to kill. So we just need to use kill space-9 and then the ID of this process, and it will be killed.
In this video, you will learn to define basic Linux commands and their uses.
Now we have the remove command that is represented by rm. It will, if we use rm to remove a file, if we use the flag -i and the name of the text or file that we want to remove, it will display the confirmation before removing the file. So this is very useful in case you don't want to delete or remove that specific file. Sometimes you have a directory that contains subdirectories, and you want to delete all the folder with all the information in there, but the system don't allow to delete until you add the flag -r that will remove all the files in there. If you don't add the -r, it won't let you delete all the information. So you just need to go delete one by one. So in order to avoid that, it is just simple than adding -r in the command. In order to remove a directory that is empty, we just need to use the rmdir command and then the name of the directory that you want to delete. Then we have the copy command that is used to copy files or directories. The command is cp. If we use the flag -p, it will preserve the mode of ownership and the timestamp. But if we use the -i, it will overwrite the information. So it is really important to make sure we're using the correct flag here. So in order to use the cp command, we just need to use cp, then the flag that we're going to be using, the file that we are want to copy, and then the file that will be overwritten as well. Then we have the the move command that is represented by mv. And it's basically the same of the copy command. If we use the flag -I, it will overwrite the existing file. But if we use the -V, it will be explaining what is being done during the movement of the file. So basically, we just need to use mv and then the flag and then the file that we are going to be moving and the location of the file that will be saved or moved, the file. Then we have the cat command that will display the content of the text files. And also we have the mkdir that is used to create directories in the different path locations in our distribution. So if we want to use cat, let's see the information that we have under books directory. We want to see what is the information that this is my test file contain. So if we use cat and then the name of the file, it will display the information that is in that specific file. Then if we want to create a directory, we just need to type the command mkdir and then the name of the directory that we want to create. I'm going to create test3. And if we run ls to see what is the information in there, we will be seeing the test3 created as a folder. Now, maybe you're wondering, what about if we want to create a directory with some subdirectories? Well, in this case, we just need to use the flag -p, and it will be creating all the subdirectories that you want to create as well using mkdir. Now we have the ifconfig command that will display all the information about the network interface on the Linux system. If you want to see all the interfaces along with the status, you just need to use the flag -a. If you want to start or stop a specific interface, you just need to use up or down command along with the ifconfig and the interface. So in this case, we're using ifconfig. It's under 0 and up. This means that this interface will be going up. If you just want to shoot down this interface, you just need to use down. Then we have whatis command, that it is very useful command. It will display a description about a command. So if you really don't know what that command is used for, you can use whatis and then the command name, and it will display the description of that command. So it is basically the same of the man command, but it will just display the description. The man command will display all the information and the flags that you can use with that command. Then we have locate command that it will help you to quickly search for the location of a specific file or maybe a group of files. So you just need to use locate and then the name of the folder or file that you are looking for, and it will display all the path files that contain the name that you're looking for. Then we just have the tail command that will be used for view the end of a text file. For example, the last 10 lines by default. You can print any number of files from a specific file. For example, tail-n, and then for example, we can use 4, 5, or any number of lines that you want to see of file name .txt, and it will just display that information from the last n number of lines you want to see. Then we have the less command that is very useful for huge log files. When you're doing a troubleshooting, for example, or investigation, and you have a very big logs files, and you just need to see all the information. With less, you will be seeing the information needed, and it won't display all the information at the same time. So if you hit the space key, it will be showing the information as soon as you hit the key. So it won't display all the information at the same time. So it is really useful for investigations with big log files. Also, you can use Control F or Control V to forward one window or backward one window. They are very useful keys and commands that you can use for investigations. Then we have the su command. It is used to switch to a different user account. So you can execute a single command from a different account name. So for example, in the following example, John can execute the ls command as rash username. Once the command is executed, it will come back to John's account. Also, you can use su command to just switch to, for example, my user, a campus, to root user. So you just need to use su space dash u and then the user account that you want to switch. Then we have the wget command that is very useful to download software, music, videos from internet. Sometimes we have our environment and we need to do an upgrade, and instead of downloading the file from the internet, then copying the file to our environment, it is just simple to use wget and the URL where the software is located, and it will just start downloading the file directly to our system. So wget, it is very useful for downloading software to our environment without doing the copy and downloading the file in different ways. So those were some basic commands that we can use in our distribution. Of course, there are a lot of more commands that we can use, but those are the basic commands that we can use.
In this video, you will learn to describe the installation steps necessary to use Samba.
Now we are going to talk about Samba and the step-by-step installation. So let's suppose that we already have our virtual machine and we have our Linux distribution installed. In my case, I'm using the Ubuntu distribution. You can use CentOS or Linux. But what is Samba? So Samba is an open source or free software suite that provides seamless file and print services. It uses TCP ITP protocol that is installed on the host server. If you configure correctly this software, it allows you to interact with the Microsoft Windows client or server as if it is a Windows file and print server. So it allows for established communication between Linux and your server. So for example, I have here my Linux distribution and I just want to share files or information between my Windows host and my Linux server. So we're gonna learn how to do that. So basically, we just need to run the following commands on our Linux distribution, and we will get the Samba installation. Then, as soon as it is installed, we will see the following file that is under etc Samba, and we just need to do a backup of this file because we need to add some lines in there. So in order to do that, with the cp command, we're gonna copy the etc Samba smb.conf file under etc Samba smb conf. adding that back station that represents a backup. So as you can see here, I already did the backup of my SMB config file. Now we just need to edit the file, and we can just use Nano or VI to edit this file and add the following lines. We just need to copy this information and paste it into this file. It doesn't matter the order, but we just need to make sure that we have all the lines in that file. Then we just need to create a directory with the mkdir command. Our directory is under Samba, and the name is Anonymous. Then we just need to set up the permissions for this specific folder, and then restart the service that will allow us to establish the communication. The name of the server is Samba, so we just need to use service smbd restart. As soon as we do that, we just need to jump to the Windows host, in this case our computer, and under network folder, we just need to add the IP of our Linux box. In order to see the IP, we just can use ifconfig, and it will display all this information, the IP, the interface, and everything. If you want to create a folder, but with a password or secure folder, we just need to edit the same folder, the same file, but we just need to add the user and also the following lines to create a folder with a specific password. In this case, we are creating this folder with a secured name under Samba, and then we are providing the permissions to that specific folder. And also we are adding the following lines under etc Samba smb config file that was created during the installation of Samba. Then we just need to restart the service, and we will be able to see the secure folder in our Windows computer. And if you try to double click and access this folder, it will be requesting the user and password. So thank you guys for your attention. This was the basic Linux training. We just saw a few commands that we can run in different distributions on Linux. Also, we saw the way to establish communication between Linux environment and Windows host environment. So hope you can try to run some commands on your side and practice a little bit more about Linux.
In Module 4, you will explore the principles of cryptography and then dive deeper into cryptography and encryption. You will learn how authentication and integrity play a key role in cryptography. Finally, you will acquire a knowledge of key distribution and certification, hashing, PKI, and certificate authorities. Encryption concepts like in transit and at rest will be explored. Why is it so important to understand cryptography and encryption concepts? Let's find out. In this video, you will learn to define cryptography and encryption, describe the related Open Web Application Security Project, OWASP, Top 10 Project, and SANS Institute Top 25 Cryptography Weaknesses.
Hi everyone, my name is Dmitry Beryoza. I'm a member of IBM X-Force ethical hacking team. Penetration testing is a type of testing where you pretend to be an attacker, an adversary, a hacker, and you try to break into the product. And as part of our work, after we do the testing and we find security vulnerabilities in software, we pass them on to development teams, and they use them to improve product quality and secure the products. So today we'll talk about cryptography. Encryption and related cryptographic mechanisms such as hashing or digital signing, they're used to safeguard customer data and its integrity. and also prevent unauthorized access to it. Today we'll be talking about common mistakes that we see in applying cryptography in our products, and we will not be talking about cryptography theory or algorithm implementation details. Those are huge topics. They're subjects of whole university courses and some really thick books. There's also something called Open Web Application Security Project, OWASP. And if you're not familiar with it, I highly recommend it if you're building applications that are web-facing, which is probably something that most of us do these days. It's a very useful non-profit organization. They publish a lot of recommendations for securing your products, and they also publish something called Top 10 Common Vulnerability List. And as you can see, in the years prior, sensitive data exposure that's related to data not being secured with encryption has not only been featured on the top 10 list, but also has grown in prominence in the past few years. So it's becoming more and more important and more common. Also, there's something called SANS Top 25 list. I also strongly recommend that you familiarize yourself with it because it lists top 25 most dangerous software errors. And as you can see, there are at least 4 different types of errors that are related to cryptography that are featured on that list. And also to show that this is not a theoretical discussion, this is just a small sample of cryptography-related errors and vulnerabilities that were recently in the news. And it really took me like just a couple of minutes to come up with these links. And if you do a search, I'm sure you'll come up with more. So in this particular case, in Twitter software, there was a mistake made, and passwords that should have been encrypted were actually exposed in plain text. And another company, Kaplan Health Systems, they lost control of their private business data and personal data of 43,000 patients when a laptop was stolen. That means that that data was not encrypted on the hard disk. So, as you can see, these are very common types of issues, and they're actively being exploited every day in attacks out there.
In this video, you will learn to describe encryption and common types of encryption algorithms, define cryptographic terms including hash function and digital signatures. So to start, let's just do a small refresher on the basics. So encryption, of course, is a process of encoding data in such a way that unauthorized parties could not access it. And it's important to say that encryption only provides confidentiality guarantee. Somebody could still modify the data, the encrypted data, and if it's just encryption algorithms that you are using, you may not notice that the modification was made. And actually later on I'll talk about a specific type of attack that's related to that. It is possible to modify encrypted data without decrypting it and still be able to abuse the application. So it's also important to apply integrity mechanisms to the encrypted data that you're using. Data can be encrypted in 3 general scenarios. At rest, which is anything stored in files, databases, backups on mobile devices. Data can be encrypted in use. So when your application is running, you're loading data encrypted, and probably it's a good idea that it stays encrypted right until the moment that it's used. So encrypted in use means that data is in computer memory. And also encryption in transit. So when data is being sent over the network. And in this day and age, sensitive business and personal data should be encrypted at all times, everywhere. We're at that point where that's absolutely necessary. And the importance of this has risen dramatically in previous years because of, first of all, enormous volumes of sensitive information being collected and stored and accessible online. The dramatic increase in the number of breaches
if you just open the news, I'm sure every week you would see something related to a computer security breach and exposure of sensitive information. And also, governments all over the world are reacting, and they're introducing new legislation to deal with these types of attacks, and they will actually hold businesses liable if they're not encrypting sensitive data. So new legislation is another factor. There are different types of cryptographic algorithms. The biggest two are symmetric key encryption and public key encryption. And as you can see from these diagrams, symmetric key encryption uses a private key. Data is encrypted using it, becomes scrambled, and then when it's time to decrypt the data, the same key is used to reverse the process to get the plain text back. It's fast. The algorithms we use today for symmetric key encryption are pretty fast, but there's a difficulty associated with sharing of that key, because very often you don't only need to encrypt the data, but you also need to send that encrypted data somewhere, and you need to send the data safely and also the key safely. So that's a big problem that public key cryptography attempts to solve. There are a number of algorithms that you probably heard about: RSA, elliptic curve, Diffie-Hellman, and in public key cryptography, there are actually a pair of mathematically linked keys that are created, a public key and a private key. And the way this works is, let's say I want to send an encrypted message to my colleague. My colleague creates two keys. One of them is private, and he keeps that very secure. But the other one is public, which is he shares with the world. And the way this works is I can take his public key, encrypt my message that I'm sending to him, and he will only be able to decrypt that message with his private key that he keeps secret. And that enables all kinds of people to send him messages and not be able to see messages that the other person sends, because the only person that can decrypt those messages has to be in possession of that private key. So it solves the problem of sharing the key, but these algorithms are generally slower than symmetric key encryption algorithms. Another important concept that we'll talk about is hash functions. They map data of arbitrary size to data of fixed size, and they work as a checksum of sorts. So they provide integrity guarantee, but not the confidentiality. So they have to be used together with encryption algorithms. So you probably have seen these algorithms before, use them in your work, MD5, SHA-1, SHA-2, SHA-3. The original data in these scenarios is deliberately hard to reconstruct. So let's say you take a file, you create a hash of that file, and then if that file is modified, let's say maliciously, and you take another hash of that file, the hash of the modified file will be very different from the original hash. So that way we can have a small checksum that verifies integrity of a huge data block. Hash functions are used for integrity checking, and they're also sometimes used for sensitive data storage, such as passwords, and we'll talk a little bit about that. Another important concept is digital signatures. It's a mathematical scheme for verifying authenticity of digital messages and documents, and actually uses two of the concepts we've mentioned so far, hashing and public key encryption. And the way it's done is, let's say, a message that's sent from one party to another. It is hashed, and the hash is signed with a private key. And the receiving party can, when let's say the message or the file is received, can verify the hash and also use the public key to verify that the hash was not altered. So it actually ensures three different things. Ensures authentication. You can be sure that the party that sent the message is really the party that is claimed to have sent the message, because only that party should be in possession of the private key. It ensures non-repudiation. That means that that party cannot deny that they ever sent the message, because it was signed with a private key that's only in possession of that party or person. And also ensures integrity. making sure that the message or the file was not modified in transit.
In this video, you will learn to describe common pitfalls of cryptography.
So let's talk about some common problems associated with the use of cryptography in the products that we see. So the first very obvious one is missing encryption of data and communications. Products handle all kinds of sensitive business and personal data, and very often data is one of the most valuable asset that a business has. So when you store it or transmit it in clear text, it can be easily leaked or stolen. So that's a huge danger. And in this day and age, there is no excuse for not encrypting data that's stored or transmitted. There was less focus on it, let's say 10 years ago, 15 years ago, but these days it's absolutely vital that this is done. And we also have the very mature cryptographic technology. It's well tested, and it's available for all environments and programming languages. So it's really, you don't have the excuse not to use it in your products. So our recommendation is to encrypt all sensitive data you're handling, and also ensure its integrity, because as I mentioned, encryption provides confidentiality, but not necessarily the integrity. Product owners that we talk to choose not to encrypt certain data because they say that users of their products don't have access to the file system the product is running on. Unfortunately, that's not a good excuse, because there are plenty of vulnerabilities out there that may allow exposure of files stored on the file systems, such as config files, databases, key stores. And these vulnerabilities are, for example, path traversal, local file inclusion, XML external entity attacks. So the attacker, what they could do is they could have what we call a kill chain. They could have a set of vulnerabilities that would abuse when they're attacking a particular business. And let's say path traversal could be one of them. They could steal a database that contains sensitive customer data and then rely on the fact that weak cryptography was used or no cryptography was used, and decrypt the data and use it. So, and actually another danger is that physical machine that the product is running on could be stolen. Hard disk could be accessed directly. So if the data is not encrypted, it will be leaked and abused. So the general rule of thumb is that you have to assume that the files containing sensitive information may be stolen, may be exposed and analyzed by the attacker. It's just something you have to go on. That has to be a basic assumption. Another problem that we sometimes see is implementing your own cryptography. Often developers use obfuscation and not cryptography. So you may be familiar with something called base64 encoding or XOR encoding and similar obfuscation schemes. Unfortunately, they do nothing for keeping the data secure. They're very trivially analyzed and reversed. So it's not to say that you shouldn't use those schemes, but never think that because, let's say, you base64 encoded something, that makes it secure. It won't. And sometimes we even see products implement their own cryptographic algorithms. And it's just very dangerous practice that you definitely shouldn't do. Such algorithms never stand a chance against a serious attacker. And interestingly, there's something called Schneier's law, and Bill Schneier is a renowned cryptographer and coincidentally an IBM Resilient CTO. And what he wrote was, anyone from the most clueless amateur to the best cryptographer can create an algorithm that he himself can't break. It's not even hard. What is hard is creating an algorithm that no one else can break, even after years of analysis. So it's very possible that the algorithm you yourself come up with, you cannot figure out how to break it, and your colleagues couldn't either. But if you're, let's say, if your product you're developing that you're putting that algorithm in is securing data that some, let's say, nation state is after, those guys have very qualified people, brilliant mathematicians and cryptographers, and they'll probably easily be able to break the algorithm that you came up with. So please don't do that. Do rely on proven cryptography, the one that was scrutinized by thousands of professionals, mathematicians, and cryptographers. And there's a National Institute of Standards and Technology in the US, and it provides guidance on what algorithms are currently considered as secure. So check it out. It's something, it's a good idea to use it in your work, those recommendations. Another thing that we see is some products rely on their algorithms being secret. They just say, well, we have compiled application, it's all machine code, the attacker will never know our internal algorithms. Well, if you think that, well, I have bad news for you, they can and they will be discovered. It's only a question of how motivated the attacker is. There is actually a whole branch of hacking called reverse engineering, and it's devoted to discovering hidden algorithms and data. So there actually are contests out there ongoing where hackers compete on who can reverse a particular application the fastest. So people do this for fun, if you can imagine. And just imagine if there is some financial incentive there to discover your secret algorithm. So again, it doesn't stand a chance. Even if your application is only shipped in compiled form, it can be quote-unquote decompiled. Languages such as Java and Scala and others that go against Java virtual machine, languages such as C# that are compiled for .NET virtual machine, Python and other languages, they're trivially decompiled. You can basically recreate the original source code from the compiled representation. So if you give me a jar file, for example, if you're a Java developer, I can most likely decompile it for you and give you back your original source code. It's that bad. And even for languages that are harder to decompile, such as C and C++, because there are all kinds of optimizations done on the machine code, still special tools exist that sort of recreate a C code that resembles your original source code. So it's all easily reversible. Attackers also, like if you rely on your product being expensive and attacker not getting hold of it, it's possible that they would get a trial version that they will analyze, or just get a stolen copy somewhere on the dark web. And also, unfortunately, the reality is that sometimes there are rogue employees that may reveal company secrets. There was research done recently that found that more than a third of employees, when asked if they were willing to sell private company data, proprietary information, agreed to do so. And some of them agreed to do it for as little as $155. So you can imagine, you could have a very secret algorithm that's only kept on company premises, not shared outside the company, but it really only takes, some, rogue employee, so to speak, that's financially motivated to steal it and sell it to the bad guys out there. So relying on algorithms being secret is not a good mechanism. It's something called security by obscurity, and it's no security at all. And actually, the contrary is being proven all the time. All algorithms that keep us safe today are open source and very well studied. So AES, RSA, SHA, and all others, like all our banking, communications, everything we use technologically today relies on open source algorithms that are very well known. And actually that's their strength, because so many people have looked at them and scrutinized them, so that all the bugs have already, or most of the bugs have already been worked out. So bottom line, do not rely on your algorithms being secret. Assume that they will be known to the adversary. And there is also a great guiding rule here called Kerckhoffs's principle. August Kerckhoff was a Dutch cryptographer in the 19th century. And what he said was, a crypto system should be secure even if everything about it except the key is public knowledge. I think it's a great principle to use in your work. Another pitfall that we see is using of hard-coded, predictable, or weak keys. Not safeguarding your keys can pretty much render your cryptographic mechanisms useless. It's basically the keys to the kingdom. So if you don't control them, if you expose them, then somebody can just use them and use the algorithm that you use to encrypt the data to decrypt it. When the passwords and keys are hard-coded in the product, and unfortunately we do see that from time to time, or they're stored in plain text in the config file, they're easily discoverable. If you have an encryption key that maybe is not encoded in plain text somewhere, but it's easy to guess, attacker could discover it by just trying commonly known passwords. There's something called ROCU lists out there, and there are many other similar lists, and it currently contains 14 million different common passwords. So let's say if you are using your email account and you have some password that's not truly random, there are high chances that it is actually on this list already. So attacker could just try all the passwords on this list one by one, and then be able, let's say, to get into your email account or decrypt some data that you encrypted with a common password. Also, when the keys are generated randomly, they have to be generated carefully from a cryptographically secure source of randomness. Let's say if you're a Java programmer, but the situation is similar in other programming languages, there is something called Java util random, and it's a random pseudo random number generator that unfortunately the numbers that it generates are very predictable. So if you generated your encryption key using that source, they can discover your key just through brute forcing. So instead, if you're generating encryption keys, you should use something called java.security.secure random in case of Java, and there are similar variants for other languages. It's a cryptographically secure source of randomness, and it should be used when generating encryption keys. So the recommendation is to rely on hard-to-guess, randomly generated keys and passwords that are stored securely. Another problem that we sometimes see is that encryption is export-controlled. So any code that either contains encryption algorithms, calls encryption algorithms from other libraries or components, or directs encryption functionality in other products, all of them must be classified for export before being released.
In this video, you will learn to describe the digital state of data, data at rest.
So let's go through different types of encryption. So as I mentioned, rule of thumb is to encrypt all sensitive data at rest, files, config files, databases, backups, anything of value. And semantic key encryption is the most commonly used for that. You can follow NIST guidelines, that's the National Standards Institute, guidelines for selecting appropriate algorithm. Currently it's AES with the CBC mode and triple DES. Those are the ones that were approved. Unfortunately, there's a number of ways of doing it incorrectly. First of all, some algorithms are outdated and no longer considered secure. You have to phase them out. For example, DES, RC4, and there are some others. So you have to be very careful. As time goes on, some encryption algorithms become insecure because vulnerabilities are discovered in them, or computing power becomes such that it's now possible, or now you can probably break an algorithm within a reasonable time, given sufficient computing power. So watch out for that and migrate to more secure modern algorithms. As I mentioned, using hard-coded, easily guessed, insufficiently random keys is a huge problem because your encryption is as secure as the key that you chose and how well you safeguard it. So you have to select cryptographically random keys, and also do not reuse keys for different installs. Because let's say you have two customers, let's say you somehow embed the same encryption key in both of them. One of the customers has a rogue employee that steals that key, sells it on the dark web, and then an attacker could attack the second customer because they now know the common cryptographic key that's used in the product. So don't do that. Another problem is storing keys in clear text in proximity to the data they protect. Something like could be likened to key under the doormat. Keys, the only proper way of doing it is storing them in cryptographically secure key stores. Also, some cryptographic algorithms require something called initialization vectors. And those have to be chosen at random every time you apply the algorithm. If you reuse the initialization vector, that's another weakness that could be exploited. And it's preferable to select the biggest key size you can handle.
In this video, you will learn to describe the digital state of data in use.
Encrypting data in use, unfortunately, is not very often followed. Usually, product loads data from disk, decrypts it, and then just works with it. Unfortunately, it's very dangerous because some classes of vulnerabilities could expose portions of memory of the product. There's a very famous vulnerability called Heartbleed from a couple of years ago, and it actually leaked memory of the processes that were using OpenSSL protocol and leaked them over the internet. So had those products been keeping the data encrypted in memory, then this wouldn't have happened. It wouldn't have been as dangerous. So the idea is to keep data encrypted even when you load it from disk, then decrypt it for a brief period of time when you actually need it, and then erase it. And that way, there's less opportunity for it to be leaked. And another thing to consider, it may or may not apply to your product, but there's something called homomorphic encryption. And it's a class of algorithms which allow you to operate on data without decrypting it. There's a lot of very complex math involved, but some uses allow for that. So you could at all times keep the data secure and at the same time do some analysis on it. And it's just something to keep in mind. Maybe your product would make use of it.
In this video, you will learn to describe the digital state of data in transit.
So encrypting data in transit is something we're all familiar with. In this day and age, there is absolutely no excuse for communicating in clear text. Just don't do it. There is an industry consensus about it. Recently, Firefox and Chrome started to mark HTTP sites as insecure. So, the sites that use encryption for communications, the proper prefix for that is HTTPS. So the sites that communicate in clear text, somebody can very easily snoop on those conversations and discover sensitive information. So all communications should be encrypted. It's not just HTTP that goes in clear text. Sometimes remote procedure calls, database connections, and others go over the wire in clear text, and that's just not recommended at all. Please avoid that. Make sure you encrypt all your communications. TLS SSL algorithms it's the most commonly used protocol. They use a variety of crypto primitives internally, public key cryptography for authentication and key exchange, symmetric key cryptography for actual data encryption, and a server presents to the client something called digital certificate that references the public key that's to be used in the communications and the certificate authority. And we'll talk more about it a little later. Sometimes some products choose to only use symmetric key encryption, and that's fine if it's done securely. The big problem with that is how do you securely share the keys between the different nodes. So let's say you have different nodes, two different nodes in your application that are communicating. How do you securely share the private key so that it's not revealed in transmission? So what are some of the pitfalls? We see self-signed certificates being used quite often. It's basically a certificate that you generate yourself. It's less problematic for internal communications. It's a much bigger problem if your product communicates over the internet. And the proper way of doing it is actually to use certificates that are verified by established certificate authority. That way you can actually be sure that this is a certificate that comes from the party that claims to have created it. Some products, unfortunately, accept arbitrary certificates without validation. If you look at this code snippet, you may recognize it if you're a Java developer. Unfortunately, we see these from time to time in the code. Attackers basically can issue their own certificates, sit in the middle of communication between the client and the server. It's something called man-in-the-middle attack. And if your code contains this pattern, you're basically accepting any certificate that comes down the wire. So attacker can give you their own. They can talk to the server on your behalf, and they will just basically be listening on all your communications and capture all the private data. So do not accept certificates without validation. Unfortunately, validation is not enough because in these days, attackers could actually create valid certificates. They could use some certificate authority and get a valid certificate from it, and it will be validated correctly when you go to validate it. The way to deal with that is to use something called certificate pinning, and in that mechanism, the certificate that's presented is actually checked against a set of certificates that you expect to see. So you wouldn't just accept any arbitrary valid certificate out there, but only the one that, let's say, your node, one of your nodes expects from another node in your product. And that, in that case, man-in-the-middle attacks are much harder to do. What are some other problems? Sometimes products use outdated versions of the protocol or insecure cipher suites. Old versions of SSL and TLS are vulnerable. You can look up, there are all kinds of very famous attacks against them: Drown, Poodle, Beast, Crime, Breach, and there are others. They all have fancy names. But basically, over time, older versions of SSL and TLS were found to be insecure. They had problems with them. Those problems were subsequently rectified, and today we recommend TLS version 1.1 and up. So actually, 1.1 is still considered secure. 1.2 is the recommended one. If you use anything below that, you may be in danger. So review the versions of TLS you support, and there are a number of tools that can help you, automated tools. There's Nessus, there's Qualys SSL server test. Unfortunately, it only works on publicly exposed sites. There's SSL scan and SSLIs on Linux. So use that and see if you are secure. Another problem is allowing downgrade of strength to insecure versions or even to HTTP. So to deal with that, you have to lock down the versions of TLS that you support and don't support any others. Do not allow downgrade. And as I mentioned before, using HTTP is just not a good idea anymore. Of course, you have to safeguard your private keys. If you lose control of that, attackers can decrypt your communications. There's some other recommendations. Consider implementing something called forward secrecy. Some cipher suites protect past sessions against future compromises of secret keys and passwords, so look into that. There have been a number of problems with using compression under TLS, so if you use HTTP compression and then it goes over secure channel, sometimes attackers can actually figure out your data because it's compressed. So there's actually a crime and breach set of attacks that dealt with that. So it's something to be aware of, and the recommendation is if you encrypt something, so do not compress statically served pages, but try not to compress pages that change on the fly. Another recommendation is implement HTTP strict transport security header on all of your communications, and also stay informed of latest security news, because from time to time vulnerability is discovered in a certain protocol and you have to react to that in a timely fashion.
In this video, you will learn to describe hashing and its purpose in encryption, describe common pitfalls of using hashing, describe additional considerations when using hashing, define message authentication codes, MACs.
Let's talk about hashing. Hashing is used for a variety of uses. They're used to validate passwords. and we use salted hashes for that. I'll talk about that in a moment. They're used for verifying data and code integrity, and used in message authenticated codes and key hashes, and verifying data code integrity and authenticity in digital certificates. The recommended hash functions these days are SHA-2 suite and SHA-3, and there are a number of problems with using hashing incorrectly. First of all, there are a number of old, obsolete hash functions. They're now considered broken. Please phase them out. The hash function usually considered insecure when it's practical to generate collisions for it. So collision is two or more different inputs that correspond to the same hash value. And if it's fairly easy to come up with that, then your hash function is no longer secure. There are two very common hash functions that should be phased out. MD5 has been broken for more than 10 years. Collisions are fairly easily generated. SHA-1 was recently proven to be unreliable. It's not recommended for use anymore. And you can actually go to the website called shatter.io to see a demonstration of that. There are two different files shared there that have the same SHA-1 hash. Using predictable plain text that you're hashing is problematic. It's not quite a cryptography problem, but if, let's say, you hash a password and that password is easily guessed because somebody uses a list of commonly used passwords and that password just happens to be there. So when they use brute forcing, they could go through all possible combinations and come up with a hash that corresponds to this password. The fix for that is using something called salted hashes. Another actually problem with here, aside from this list, is the rainbow tables. They're a variation of lists used for brute forcing, and they're basically just gigantic tables that somebody else pre-computed of all possible combination of characters and the hashes corresponding to that. Well, of course, it's impossible to do it for, well, no, maybe not impossible, it's very hard to do it for the entire problem space, but for reasonably large inputs, it's possible to generate rainbow tables, and there's one that you can actually visit called Hash Killer. You can input some common name or a small number in there, and it'll probably give you the hash for that. And I assume that nation states are able to generate just gigantic rainbow tables and defeat hashing that way. And the way to prevent that is to use a salt. And a salt is a random byte sequence. We recommend at least 8 bytes that you add to the plain text before you calculate the hash. And you also share that salt in public. And as a result, the hash will be wildly different for the same password but different salt used. So you can see an example here. 2 users, they have their passwords encoded, hashed, but hashed with salt. And the password is the same for both users. But because the salt is used, you see in blue the hash value is completely different. And if hash is used, then rainbow tables become impractical. There are some additional considerations when using hashing. Use key stretching functions together with hashing with a large number of iterations, and they're deliberately slow, and that's controlled by the number of iterations, and they make brute forcing attacks impractical, both online and offline. And you have to aim for maybe 750 milliseconds to complete the operation. So it slows down the calculation of the hash, and if you're trying to brute force a large list of passwords, it just becomes impractical. It takes too long. So here there's an example of PBKDF2 used. And you can also future-proof your hashes, include the algorithm ID when you store the hash. That way, if algorithm later becomes it's discovered to be insecure, then you can react and, let's say, change to a different algorithm and just store a different algorithm ID in there. There's also something related to hashes called message authentication codes. And they confirm that the data block came from the stated sender and has not been changed. There's a small diagram here. So basically, the hash-based MACs or HMACs are based on crypto hash functions such as SHA-256 and SHA-3. They generate the hash of the message that you're transmitting with the help of a secret key. And if the key is not known to the attacker, they cannot alter the message, generate a new hash, and come up with the same hash. Because that's the problem when, let's say, you're sending a message and just a plain hash with it. Somebody can modify it in transit, recompute the hash, and store the new hash with it, and just send it on to the destination. With HMAC, it's not possible because the hash is actually generated using a secret key, and that key is not known, so there's no way to generate a corresponding hash. So these types of algorithms probably shouldn't be used everywhere, but only in scenarios where there's a chance that the data may be maliciously altered while under attacker's control. So let's say you are storing cookies in the client browser, you are transmitting messages. That's where HMACs will be very useful. And as I mentioned, even encrypted data should be protected by HMAC because there's something called a bit flipping attack, where attacker could play with the bits in the encrypted message, not know what's there, but they could play with it enough so that let's say they could change the amount of the money transfer that's being sent. So let's say you're sending $1,000 to someone, attacker could play with encrypted representation of that to change it to $1 million without actually decrypting the data. So that protects about bit flipping attacks.
In this video, you will learn to describe recommended uses of digital signatures.
There's also something called digital signatures. They ensure that messages and documents come from authentic source. They were not modified in transit. Some recommended uses for that are verifying integrity of data exchanges between nodes, code transmitted over the network for execution, so applets or JavaScript or Android or iOS applications, they're all digitally signed to verify authenticity and integrity. Service packs and fixed packs that a customer installs, so that has to be protected by digital signature to make sure that somebody didn't play with it, didn't put something malicious in a server pack they're applying to the product. Data temporarily saved to the customer machine, for example, backups. And to be useful, they have to be verified. If you create a digital signature but never verify it, it's useless, it's for nothing.